Can you guys hear me? Very good morning, Arad. What about others? Disi, Ekta, can you guys hear me? Thank you, Arad. Oh, yes, it's going on, I think, from the last week. So, yeah, still has that. So, I will not turn on my camera because you guys know that somehow in my system, Zoom did not work properly. If I turn on my camera, my system just goes down. So, sorry for that, guys. I hope you guys are okay with that. Yes, I don't know, like it didn't happen earlier, but recently, I think from last 2, 3 classes, I have started observing this. If I'm not turning on my video, the class is going fine. But if like how many time I have turned on my camera, it just somehow it happens. So very good morning, guys. Again, I know we have discussed last class some of Q's problems, right? Yes, Q's problem was there. And then we started talking about trees. So while discussing about trees, I have just given you very little informations because we have not seen the implementation till now. But I have given you the hint that the implementation of trees would be little bit similar to as we were doing in the linked list, right? So similar, the implementation would be similar to that. So if you guys has little bit interest on that, like after giving your tomorrow's test, so I would say that start looking for a tree somewhere in the blogs or in YouTube. Start understanding a little bit about it because trees and graph are very important topics, guys, for any interviews. And whatever we have like learned till now, arrays, stack, and queues, they are going to use inside trees only. So that's what I'm saying again to you guys and reiterating it. Wherever you guys got chance to work for, like learn about trees and solving problems, do it. Do not leave any single questions about trees and graphs in the because now we've started with trees. So do not leave any question of trees in lead code or anywhere. You all should be expert in trees because a lot of like in before in PayPal when I started working on PayPal. So in the interview round, they have asked me 2 question or trees there as well. Before that, I was working on Incido. There also they have asked me 2 questions on trees only. Like is there was Israel team and they have also asked first they have asked the traversing. How can we do the traversing of trees? So they didn't ask theoretically. They asked me to write a code for that. So the coding was there just for traversal, and then they just provided some one more questions on that. So there was 2 questions there as well. So that's what, guys, trees and graph are very important topics for an interview preparation. So I would suggest to everyone that please now take these classes and like whatever practices you guys are doing, please do it little bit harder now because these are the topics which are going to like you will see it anytime you will change your organization. Like if I want to change right now any other organization, my organization to any other, I have to prepare trees and graph for any interviews. So guys, it's very important topics. Yes, important and interesting also. Definitely. Because a lot of questions are there. Like in the graph, if I talk about, there are shortest path questions. And those questions are very easy actually. Just you should know like see again the visualization with the coding every time visualization comes plays a very important roles actually. So like while solving shortest path questions or digestras problems, All those problems are just on the visualization. Once you know the visualizations, once you have the visualization of the problem, then you just need to simply use looping and cues and stack. These three things, just little bit logic. Like while you are iterating, you need to store these values somewhere or not store some value, not store values. You have to go into each directions. That's all. So that's what, guys. These are very interesting topics. Definitely, I think I agree with Arad that it's interesting as well. And again, the visualization comes into the picture. And see, guys, the visualization, it will happen only when you will practice these problems. Like daily, you're spending half an hour or 1 hour with these problems. Automatically, visualization will come into your mind. It's not like automatically it will come in one day and then you will realize that now I'm perfect. No, it will all come with practice. Give some hours to these problems, these suggestions, you will automatically get it. Okay, guys. So that's all I want to talk to you guys about it. By the way, if you guys have any thoughts or anything, because today you can just simply unmute yourself and talk about it. Why not do that? Because in our relevant platform, it's difficult, right? You guys can today talk about it as well. And I'm totally happy to talk with you guys. So anyone wants to talk about anything? One by one, everyone can go on. So like you guys tell me like how is your practice? How you guys are practicing these days problems? Everyone using lead code? So you guys are so much familiar with chat, huh? Everyone is writing there only. Okay, so Arad is saying yes. Vishal is also saying yes. Ekta is also saying lead code. What about others? Hariharan, Manoj, Nayan, Parag. Where you guys are practicing? Disi, Chandu, Sachin. Where you guys are practicing? So Ekta is saying she has completed 142. Very nice. Congratulations, actually. It's very nice, actually. The speed and the progress which you are doing, Ekta, definitely it's going to help you a lot. Parag saying lead code in GFG. Okay. See, I personally go to GFG just for understanding, just for like if I am not able to understand any questions or I want some suggestions, I go to GFG. Or I also started going less there because I start coding with lead code and then I go to discuss section of that. So most of the like coding part I got there, but still I have any doubt, I'm not able to understand the logic. Then I go to GFG there. Okay, guys. But yes, lead code and GFG are good combination, guys. Nayan is saying not daily. Nayan, please do that. Please do it daily. Like whatever you guys are doing, I know that is totally important and very much important for everyone, for you as well, Nayan. But please, I am requesting you to somehow take out 1 or 2 hours and spend on coding. If you really wants to be great and wants to good compensation and wants to good knowledge as well, so please start doing these practice problems. Otherwise it will not, otherwise it will create a problem you. Yes, sir, but sometimes I get little scared. In the past, I got nervous and messed up some interviews with good companies. Yes, it happens, Ekta. So see, when we do not have any guidance, and see, I personally believe, I'm not sure about others, but I personally feel that everyone should have one, guru in their life, or somebody who can guide them. Otherwise, sometimes we just got misdirections, or might be like, see, we know that with the in the era of internet, we already know a lot of things there, right? A lot of contents are available there, a lot of motivation speakers are there, a lot of guidance are already available, but still it's really lot, and we are not sure that what would be good for us. So that's why I think still after all of these contents are available in YouTube, still we should have some guidance. The guru culture, I fully support the guru culture. While I was in IBM, you guys, like you guys won't believe or not, I'm not sure, but I have the very nice managers there. And those managers are the future thoughts. They always have the future visions. So they always suggested me that, Arpit, you should go for this line. I know that there, like while I was joining the IBM at that time, there were a lot of frameworks like React was there, Angular was there, Node was there, and I have to choose one of those, right, to go for further, to go in like further in this industry. So they have suggest they are the person who has suggested a lot to me. Like somebody said you have to go for Angular, somebody was saying go to React, but I just followed one person, and that person told me, I will go for Node.js. So I went to that line, and I'm very happy with that line. So I want to say to you guys also, that we should always have one guidance or guru in our lives who can give. See, in lot of ways are there to walk, but that person could play just the important role for in your life, that yes, like, and you have to believe on that as well. I know that because when I started at that time, data science was also in the peak. Some of my colleagues was working on data science, and the blockchain was also on that time peak. So I asked, like, again to like the person name was Hemant Sindhi. I think he's in LinkedIn. He's still in IBM. I so many times I go to him. He's, I think, in the leader right now in IBM. So I go to him. I ask him, like in IBM there is no sir culture. So we just talk simply by taking his name. So he's so senior to me, but still, like, there is no culture of sir or madam. So I just simply say that Hemant. I just take his name, first name Hemant. And I just ask him, like, Hemant, like, a lot of people are going here and there. Like, some people are choosing data science, some people are choosing blockchain, and I am working on web development. What do you suggest? Where, like, am I in the right path or not? Or should I choose, like, my move it from here to blockchain or data science? He suggested, no, actually, web is also not going to be die anywhere. And as we have seen at that time, React Native was also coming, and and still I think, if you guys not aware of, still web is not going to die anywhere. Recently you see that web 3.js has started, right? Till now we were fully working on web 2. Right now, lot of opportunities, I think, in still LinkedIn. I got a lot of calls for web 3.js, that like those all are startup, but still they are connecting to me if I want to work in their projects or not. So a lot of opportunities still are coming for web 3.js now. And now with web 3.js, I'm not sure you guys are aware of it or not, but recently I got one article of Washam WebAssembly. Right now, that's the next thing which is happening on web only, where you can use any other languages. Right now, for creating a web or browsers things, you only have JavaScript, right? Everything you write in JavaScript, like React.js is there, Angular.js is there, Angular is there, Vue is there. Everything you write in JavaScript. But with the help of WebAssembly, you can write in any languages: C, C++, Rust, Go, Java, in any language. And with the help of WebAssembly, you can run your these languages also in the browsers. So see, guys, that's what web is not going to die anywhere. And I am very happy to choose this path. And I think you guys are also going into the same directions. But right now, you are in the in the initial phase. You can, like, you are right now looking for any organization, and in after joining that organization, you have to decide which or that organization has to decide which path you have to go. But if you got a chance, so I would say that web is not going to die, and other streams are also not going to die, like blockchain and the machine learning or AI or data science. Those paths are also booming. But I would like we cannot avoid the web path as well. So a lot of interesting things are going on, guys. So definitely, I think two things comes out of it, that we should definitely have one mentor or guru. I think earlier in India cultures, we already have guru culture, but somehow we forget it. But that's definitely play a very impactful role. And I think whoever is success in their life, they definitely have they just definitely follow someone. I'm not sure there would be someone who does not follow anyone, and he goes into his own role. There are very less people like that. So yeah, so that's what actually Ekta was saying, that so that's happened, Ekta, because we messed up some of the interviews. I also did that, I'm not saying that I'm fully perfect on the interviews part. I also messed up some of the interviews. Like I went to till second round. In third round, somehow I did the mistake. You guys won't believe, in my college, let me share this thing with you. You guys might be thinking it as a funny incident, but when I was in college, the first company came there. There were Infosys, you know. So the Infosys have, I think, two rounds only. Two rounds, yes, it has two rounds. And if you guys have any experience with Infosys, yeah, Infosys. So you guys must be hearing about that Infosys has very tough quant round. Like first they provide you one testing round. Like they will test your and like aptitude skills. In that aptitude skills, they provide you three sections, similar like CAT exam. Not the same difficulty as CAT, but little bit less to CAT, because they have very difficult questions in the quantitative. Then they have English round, like there will be in English, passage would be there, sentences would be there. And then third round was the reasoning round. The three rounds would be there in Infosys, because Infosys hire everyone, like in from every branch. So that's why they do not ask any specific questions to computer science. They ask some general questions. They just want to think your analytical skills or aptitude skills. So that round is very tough actually. You guys won't believe. Just check off the Infosys aptitude questions. I'm not sure if you guys have faced any of that. That question that, and they give just 60 minutes, yeah, some like less minute to complete those things. So in my college, I was in like I have completed my BTech from the GLA University in Mathura. So in my college, actually from third year, they start preparing students. So they ask like everyone to come there, and like they hire some faculty also to prepare us for those rounds only. So like till the Infosys come, I was not good at English round, or sometime actually I got failed in the quant round as well, because quant is still fine, not fail actually I would say, but yeah, less like the cut off which Infosys has, I was not having clearing in my test round. So you guys won't believe, when the Infosys come, I think more than 700 or 800 people were sitting, and only 121 people has cleared the first round, and I was one of them. I was very happy actually, because that was the first company, and I cleared the first round of that, and that was too much difficult. So I was like full happy, because it was only 121 students, right, who has cleared this round. So a lot of my friends are like in my group, 2% has only cleared it, one of my friend also. So now I went for second round. That was, I think, interview round, where they will ask you some of the queries, like the technical queries, because I belong to computer science group. So they will ask you some technical queries. Now you guys won't believe, I was not fully prepared of that, because till now all of the faculties are just like making us perfect in the quant and English round, but there was no any mock interview rounds. I think in the GLA, I think they have gone for one or two mock interview rounds, but still in the interview rounds, no one was perfect there. So you guys won't believe, the same happened with me also. So same happened with me also. Like in the interview round, so they have asked the interviewer has asked very easy question. Now I remember those questions also. So those were very easy questions. Like I think the inner join was there. The joining question was there in the database, and I think little bit about database, because in colleges we do not work on any specific language at that time, because till fourth year I think we were fully working on some of the subjects. So that's why he asked some of the questions in database, and some of the questions are related to cloud. And guys, what is the last question he asked? Because everyone was saying you should ask them, like whenever they are saying, "Do you have any question?" So everyone should ask any question. So, and I was not fully prepared. What should I ask them? So you guys won't believe what the funny question I asked to them, that what is if you are seeing this Infosys and R, what is the R meaning in the Infosys? R mean, I know you all know it right now, but I was not aware of it. So I asked this silly question to them, that what's the meaning of this R in this Infosys? So that they are saying this This R means registered. And I'm not sure that was the question or any other of response of mine. I was not able to clear the interview round. So they have just kicked me out of the interview rounds. And I personally feel, I think my last question was not good. So that's why they kicked me out of that round, because I was just asking this silly question to them. So guys, that's what actually I want to share with you, that it happens sometime. This, I have cleared the first round that was very difficult, and I just like asked one silly questions. I till now I believe that was the question only. That's why they have not taken me in the Infosys. So so that was actually the silly questions, and then I went for IBM round. After clearing, after like kicking, they have kicked me out from there, and I went for IBM. And IBM also had, I think, at the same round there. IBM was 3 rounds actually. First they have the same quant round. After quant, they have the English and letter writing. I think that was the second round, and third round was technical round there as well. So there I asked very nice questions to them. So there I got cleared at that round, the technical one, and the last interview round, and then I joined the IBM. So that's what happened actually, guys. So because I do not have anyone there which could guide me for that question, so it happens, and I know this would happen with somebody else as well. So guys, so it's not like that it happens to you only, but it happens to everyone. Same thing happened to me, failed in interview round Infosys. Yeah, actually that happens actually. And the friend of mine who has also cleared with me in my group, he has cleared the interview round, so he has joined the Infosys. So because why I was saying about the Infosys, because Infosys is very nice. That actually when they do the training, they have very nice what do you say? I think I didn't remember the place where my colleague gone. So, but yes, they have very nice induction rounds, or like training rounds as well. Like for 6 months or 3 months, the training will be there. My friend also told me, like after he joined, he was telling that like food was very nice, and the whole, like where you will stay for those 3 or 6 months, that will be like big hotel which they have created in near to Pune, or like Mysore. Yeah, it's in Mysore, I think. So Infosys has very nice actually 6 month round, but after that it was like he was dying there. He just left that organization. He just left Infosys after some time. But yes, starting 6 months was very nice. But I was offering packages at that time. It was standard. It was very standard, Parag or Chandu. So I think at that time when I think I joined in 2018. Yeah, so it was near to like 4 LP. It was very standard. Every starting organization of these MNCs, they will just provide that much only offer, 4 to 5, that much. Infosys also provides a similar around. They are not like the higher package organization. They just give you a lot of work. So I think that's all. I think we have spent how much? 20 minutes, guys, to talking about all that. So why I just pick this topic. So I just want to tell you guys that it's not like we all are perfect, and we do not face any problems. Everyone face some problems. Everyone has his own journey, so he has to walk on that journey. So that's what you guys also choose any of the mentors, and connect with him wherever you want to go, and and do not feel scared like somebody was saying right earlier. I think it was Ekta, because slowly everything comes into the play when you start practicing and when you start walking into that. Yeah. I said I had few questions to ask. Yeah, please ask, Ekta. We can spend, I think, more 10 minutes, and then we can jump into the questions. If anyone has any
Hello.
questions. Yes, yeah, Ekta, please tell.
Sir, am I audible properly?
Yes, you are.
Yes, actually, I joined TCS around it's like more than 1 year technically.
Mhm.
So the problem is that like since I've already spent 1 year in TCS, and as you know, like there is no proper technical kind of work here, like not very core development. Although I have been shifted from 3 to 4 projects like continuously, like एक project से दूसरे project. So I do
Mhm.
not have that, proper work to show कि like what exactly have I done in 1 year. So suppose if I go to some other product based or maybe even a startup, so
Mhm.
like will they not question this कि आपने वहां पे 1 साल किया क्या? Why is like what is this work history of yours? So like how to deal with that?
So, see, definitely they are going to ask you, what is your one last year experience? So,
Hmm.
what, see, we know that only what we have done in the our organization. Same goes with me as
Yes.
well. While I was in IBM, luckily I was in multiple projects, so I was very happy. But what I did, I just taken because see, I met to the peoples, I talked with other peoples, I got to know that what they are working, right?
Hmm.
So sometime I have included in my resume or while talking with interviewer, what I did personally, I just started the base from my project, like when I in which I am working, and then I included some of
Hmm.
other parts from other projects as well, that I was working on these things as well. Because see, I am the one only which is going to tell to the other person that I work on these things, right?
Hmm.
And so that's what I did in my interview rounds. I did not tell him that I was just continuously moving into multiple projects or like that. I just told them that like I work on only two projects, and the total
Hmm.
work which I did, which I heard from others as well, or
Oh.
which I have work on mine as well. I just included everything into that one. And
Okay.
most of the time, interviewer ask, they do not ask like what are the projects you did or anything. In two of the interviews, I remember they've asked me what are the challenging work which you did in your project. That is the question which mostly interviewer ask. So
Hmm.
just think about the answer, like just sit for some 16 to 20 minutes before the interview rounds, or create one answer for this question, because definitely they are going to ask, right?
Yes, sir.
So just create one solid answer, because I have worked on, see, I really work on one of the one or two challenging projects when I was working in the financial. So I just always give the same answer to everyone in the interview, that I was
Hmm.
working on that one. I just explained them that what was the challenges I was facing and how I resolved them. So same for
Yes, sir.
you. So see,
Hmm.
these are the questions which comes into the HR rounds or other rounds. I personally feel they all have some same pattern. If you if
Right,
you
right,
just
sir.
read
Yeah.
about- yeah, if you read about that, they all have same pattern. Everyone will asking, what is your strength? What is your weakness? Right? Where do you want to see
Hmm. Hmm. Hmm.
yourself in the 5 years? Just create one
Yeah.
time, just sit for one day and create answers for all these questions in your mind, and then
Okay,
use the
sir.
same
Huh.
answers in every interview, and with the more confidence. In these rounds, I
Hmm.
personally feel how much you are speaking easily and with more confidence. HR does not look for your answers. HR just look for your fluency or
Huh.
your confidence, and you're not taking pause, you're not taking thinking. They just look for these things in this round. They do not look for what was your strength, what was your weakness, nothing.
Hmm.
I just, because I have given interviews, I just personally feel that they do not look for my answers. They just look for how confidently I'm talking about those. So that's why I'm saying to everyone
Yeah.
here, to Ekta, spend one
Hmm.
day and just search in the internet. A lot of questions are there, and just create one time all the answers for those questions. And I'm telling you, you no need to think about next time whenever you're going for any interviews, because you're going to use the same answers every time.
Right, sir. And moreover, I feel that they are probably looking for skill set of the candidate. Like for example, so I have been inclined towards personal learning for the past 6 months. Like ever since I joined, enroll for this course. So I think
Mhm.
that combined with with like some of the work experience I have, maybe I
Mhm.
can come up with good answers. It's not like they have they want to know the minute details of what exactly I did. Probably they would be looking for the skills or the technical knowledge. I feel that way.
No, no, that's totally right. Because see, first, whatever you have done in this project, you have already created one e-commerce website, right? We have created those
Yes, sir.
APIs together.
Yes, sir.
You
Yes, sir.
can tell them as well that in
Hmm.
my organization, I work on one of the backend servers, and I created all these APIs for
Yes.
that
Hmm, hmm,
client.
hmm.
Yeah, you can include that there as well. So, and you can
Yes,
include
sir.
it in your in resume as well, that I have created these
Yeah,
APIs.
sir.
and I think I already suggested this earlier to everyone there when we were completing the e-commerce website, that in your LinkedIn, put this content there in your resume as well. Put some postman screenshots, because you do not have the UI at that time, right? So you can
Yeah.
put some of the postman screenshot. People will see that yes, you have work on it. So
Mm-hmm.
that's what definitely matters.
Yes, also nowadays they simply like go to our GitHub profile and like scan that. So
Yes,
even there, like I have kept all, like there are a total of like 10 to 15 repositories for even for DSA and also. So I think that would also help, right?
correct. See, whatever problems you are solving, Ekta, or
Huh.
others as well, like Arad was saying, yes, so put it into LinkedIn as well. I have seen like some people are saying 100 days of lead code, or this with these flag. If you will put it here, so any interviews, because a lot of big organizations like Amazon or Atlassian or Google, most of these interviewer look for your profile in LinkedIn. So when you will put
Okay.
all these things in your post, so they will see
Mhm.
that okay, this person is solving these problems from last 100 days or last 60 days. So it will give one impression to them that this could be good candidates for DSA rounds,
Yes,
right?
sir. Yes, sir. Definitely. The
So,
like.
so start doing that as well. And I'm just suggesting this to everyone. If you guys are solving any of the problems, please try to put it in your LinkedIn profiles, because these organizations, they see looking for resumes. It's okay, that's fine. People like very quickly they just look in the resume for 2 seconds, and then they just simply swipe for next one. So that's why go for these LinkedIn and go for LinkedIn profile. Go into your own LinkedIn profiles and put all the content which you're doing. It definitely will make some differences. Okay, guys.
Thank you,
Okay.
sir.
Do you guys have any other questions? Anyone else? Vishal, Shashan, Arad, Manoj. Vishal is doesn't have any question. Dishi, Chandu. Okay. So we don't have any questions. Okay, so let's now talk about any specific questions from, I think our last revision class was after linked list, right? And after a revision class, we have started stack, and then we started queues, and one of the class we have done on advanced question on linked list as well. And then I think yesterday's class was on advanced question on queues and stack, yesterday or before that as well. So now you guys have any specific question in your mind where you stuck on logic or on the coding part? We can start looking into that one. Otherwise, we can go from the slide one. I have already taken out some of the URLs here. So from there, we can go into the class as well. You guys are able to see my screen, right? This was, I think, the first one from where we have started the stack part. But let me first see if you guys have any other queries specific. Okay, so you do not have any queries. So let's revise it then. Okay. Let's start a revision for your test round, yes, tomorrow. Okay. So let's go back to our slide. Okay. So now we have started with stack, right? So when we talk about the stack or queues, okay, Vishal has any specific question? Longest contiguous subarray. Longest contiguous subarray. That was the problem in sum of subarray ranges. Ah, yes, this I remember. Sum of subarray ranges. This was nice question. Vishal, this question was in which slide? Is it in Slack one? Longest contiguous subarray? Or you're talking about the sliding window problem? There was one sliding window problem where we have to find the maximum. Okay, we'll see that. And sum of subarray ranges. Yeah, this question I remember. This was in the stack. Sum of subarray ranges. Longest contiguous subarray. We'll see that. Okay. So let's now quickly revise it and then jump into these questions whenever they will come into our flow. Okay. Okay, guys. So let's start with the stack. So when we were started talking about the stack, so We have talked about some of the examples, right? I remember I have given you guys the example of chairs, right? In the marriages, mostly we have seen that that we mostly keep the chairs on top of each other, right? Like when the marriage ends and when they are going to take out all of the chairs, say them they what they just, normally do, they take one chair and they keep next chair on top of it, then next chair on top of it, next chair on top of it. That was the first example I have given you about the stack. And the second example I remember, I think, yeah, the second example was also on the marriage only, right? The plates, right? Which we use for taking a dinner there. So the plates, the pattern which they follow in the plates also, that's also looks like a stack. Whatever the first plate they have kept it, that plate will be used at the at the last time only. And whatever the last plate which is on the top, that will be used as the first time. Correct, guys? So that was the two examples. With those examples, we started understanding about the stack, and we told that these are this example which follows the pattern of last in first out or first in last out. Correct? LIFO or FILO. That was the terminology which we have given for stack. Do you guys remember that? Let me know in the chat. Yes. Yes. So okay, yeah. So that was the like pattern or strategy which we should know about stack, right? That is stack follows last in first out and first in last out. And you can see here with this book example as well. It's also these books are also kept in the stack manner. You can see the Python book which is on the top. If somebody wants to take a book here, he will be taking the Python first. Otherwise, he can't take the physics book from the middle. He can only take the book Python, then calculus, then physics, then music, then history. Right? Okay. So that was about the stack, understanding about the stack. And stack and queues and linked lists, these are linear data structure, right? They follow some order, right? In last class also we have discussed about the linear data structure. They follow one order and they run into one label. They all, when we do the traversing, we do it on the one label only, one directions, right? Like four, like if there is four, I've already shown you this example in last class also when we were talking about the trees, that how the trees can go into the multiple labels. But in the linear data structure, they work, they all are uh, put it into one linear manner or in ordered manner. They follow one sequence while traversing or while storing data. Correct? So that's what these stack and queues and linked list are linear data structure. So these two things you need to remember. If you got any questions in your tomorrow's test about the linear data structure, so you should remember stack is also a linear data structure and it follows LIFO and FILO, because I personally feel these questions could come into your interviews. Oh, sorry, in interviews or in your test as well. Okay. Okay, let's see from the next slide what can come into the. Okay, now the operations of a stack could also come, right? So now you can see these are some of the operations which any stack has, and the important one, the is important operation which any stack has, which is push and pop, right? Push means insertion of element in a stack, and pop mean deletion of that element from the pop, right? Very simple definitions of push and pop. Then we have some other operations which helps us to get to know the state of stack, like is empty. So it will tell us that our stack is empty or not. So that will be, this function will be there. Then overflow and underflow, and I'm sure you might get this question in your test tomorrow. What is overflow and what is underflow in stack and queues? Can anyone wants to tell it quickly? I want you guys also to remember and talk about it. We can make this session collaborative, right? Anyone wants to talk about or want to write it in the chat? What is underflow and overflow? Because the same definition goes in queues as well. Okay, so nobody wants to talk about it, huh?
Hello.
So,
Hello.
yes, yes, Vishal.
Can you hear me?
Yes, yes,
Hello.
I can. Yes, I can.
So first talk about let's talk about overflow. I think so.
Mm-hmm.
If suppose we have given an array, and
Mm-hmm.
that array has limited size, like only 5 or 10 elements has to be inserted in this array, and and if we are inserting element, I think greater than the size that was given, then
Mm-hmm.
that scenario could be termed as overflow.
Correct. Totally right. What about underflow?
And like if like similar case, if the array is empty and we want to delete element, but there are no element in that array, then this is the case of, I think, underflow.
Totally right, Vishal. Thank you for your answer. That's totally right, guys, which Vishal has explained here. That if you have an empty stack and now you want to delete any other elements, or if you want to do the pop operation on empty stack, that would come under the underflow condition because you do not have a resource. What do you want to delete it? So that's what the underflow situation. And now the overflow situation is, guys, when you have a stack or which has that stack has a limited size, like 15 elements can be only inserted, right? Now you have already inserted those 15 elements, and now if you again wants to insert the 16th one, so that would come under the overflow conditions. And I remember you guys might have seen the one of the errors of stack in the JavaScript. I think you mostly seen this stack overflow, right? Because when we leave our loop without closing it, so that goes into the stack overflow condition. Like if you're calling any functions and that function is not going to stop it, then you will get the stack overflow errors, right? Now Hariharan is saying how the stack size has been fixed. So like limited size, yes, it's limited size, totally right. See, we always, whenever we talk about anything, everything has a limited size, right? My system also has 8 GB memory, right? Or 32 GB memory. If I'm trying to keep more data than that, it will we can't do that, right? So that's what the overflow condition. Same happen in stack as well. Whenever we create any stack, we provide some limited size, and when we provide a limited size, so when we kept those elements, whatever the size we have provided, after that, whatever we are going to keep, that's going to out of it overflow. You know, in simple word, like if we have a bottle and now that bottle has been filled fully with water, so now if we want to keep more water, if we want to fill more water, it will overflow, right? That's what the same example is here in the stack as well. Understood, guys? Overflow and underflow, everyone? Yes, recursion without base will also go into the overflow. Totally right. Okay, now let's move into some of the other operations. Overflow, we're done. Initialization. Oh, that's the initialization of stack. Okay. Then I remember we have talked about we can initialize our stack with two ways, which is the arrays and linked list, right? Before jumping into the queues, this was the only two ways we can create our stack, one with the help of arrays and one with the help of linked list. We have not tried the linked list, but in yesterday class, yes, in the Saturday, yeah, it's Friday, sorry, in the Friday night class, you guys have seen it when we implemented queue with the help of linked list, and you guys was observing there every operation was every operation was constant there. Push and pop or NQ or DQ. Those all operations were constant time. I, do you guys agree with me on that? So pop and push, NQ and DQ, all these operations are constant time if we are going to use the linked list. Agree, guys? Okay. So, but you guys also know that we can implement a stack with the help of queues as well, right? And same goes for queues as well, that we can implement queues with the help of stack as well. With the help of two queues, we can implement stack, and with the help of two stack, we can implement queues as well. And I'm sure in the test, you might be getting these questions or the code of it. Anything? I'm not sure about in the test. You also got the coding, or is it just the objective questions? You guys tell me in the answer, or anyone can speak as well. What happened in your test? I'm not sure about it. Is it all the objective questions, or you guys got subjectives as well? Like you have to write the code and write the theory about it. Vishal, Arat, we are sure of getting questions on binary trees, but we have not covered the binary trees. Why would you get the question on binary trees?
Sir, that was mistake.
Uh,
I mean mistake from the team.
okay.
And sir, we get
Hmm.
MCQs.
Okay, but my question.
Yes, sir. Sir.
Yeah. What are you saying, Arat?
Sir, I'm saying that they gave us MCQ question and some DSA questions.
Okay, so yeah, Ekta has also written that 30 MCQs and 2 DSA questions.
2 DSA question. And there's a
I see.
development phase.
Good. I think, yeah, it's a mix of everything. That's nice. So see, these 30 MCQ questions will give you the understanding or to talk in your interview rounds, because in interview rounds they will be looking for whatever solution you are applying, you know the basic logic of them or not. So those 30 MCQ is going to check that part. And to DSA question, I think they are going to check or test your coding skills, right? That you have better coding say there or not. And I think third round is feature development. Yeah, so like how you are designing any solution, that could come in the feature development. And fourth round is optimizing the third round. Okay. So like the fourth round is the best one. You have to use your 100% mind to optimize the solution. Great. Okay, so let's jump into the next one. So this is the initialization of our stack, guys. So in stack we have, because we are going with the arrays, so we'll keep all of our data in the arrays, and then we have the top for tracking, because in stack we have already discussed that everything go out of the everything which we insert, we kept it on the top, and then whenever we are deleting, that will also go from the top. So that's why we want one variable or pointer, whatever you want to say, to track our top. Next we have our code, right? You guys can like stop me anywhere you in any of your methods if you guys got stuck. I'm just like going to the next slide. I will come it after it to chat. If you guys want to stop me anywhere, just let me know. We have not talked about the peak. So peak is like whatever element is right now is on the top in the stack. You know that there are multiple plates, so whatever plates are on the top, that would be called as a peak. Peak in real, like in general English also, peak means top only. Then the print method was there, and then we have the is. But yeah, let me come back to chat and let's see if you guys want me to cover any of methods. No, I think yes, you guys are good there, right? So let's move into the next part. So now the problem has started. We have covered the stack. Now the first problem has come to us, which was insert element as bottom, right? So whatever the new element is coming, we have to insert it into the bottom. You know that, right? 1 minute. Where is my pen, guys? 1 minute. Yes, this is here. You know that, right? In a stack, when we insert an element, like insert 5, it will go on the bottom. Then we insert 6, it will go here on the top of it. Then 7, then it will go here, then 8. But the question is saying to us, rather than doing this thing, every time if I'm inserting a new element, that should come at the end only. So it will look like this. First time 5, okay. Then if it's 6 is coming, then 6 should come at the bottom. 5 should come at the top. I think it is making it as a queue only. Then 7 should come at the bottom. Right, guys? Because you guys have already know about the queues. Is it not the queue only now? Whatever the first element is there, we can easily pop it out. And whatever the next element, is it not queue, guys? The insert at bottom, is it not queue? Behaving as queue, right? Yes. 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 So that's what we can say that now we are using the queues as well. And you know that with the help of two stacks, we can create the queue as well. But here we have not followed the two stack. We have used our recursion methods, right? We have used our recursion methods. So if you see the code, what we did here, we are simply taking our peak element and then popping it out of the stack and then calling the insert element at bottom again and again. Already, like you guys aware of the flow which will happen. And once the stack will become empty, we will push this new element, whatever is coming. Like after 6 is coming, like this is the 5, right? Now we'll pop it out and keep it in one temp. Once our stack is empty, we'll insert 6 and then insert temp there. And that's what's happening here. You can see, first I'm inserting, once the stack is becoming empty, I'm inserting this new element and then I'm inserting the temp here. Correct? So that's what we did in the insert element at bottom. And I think a similar question is there for reverse also, right? If you want to do the reverse as well. So that same code will be used here for reverse as well. We'll first pop everything here we'll pop all the temp element. And then whatever we have popped, we'll insert into the, insert that element into the bottom. Correct? So you guys want me to explain the logic about it, or you guys are aware of it? Can we move further on it? Or you guys want me to explain the logic in better way? Or you guys remember the logic till now? Let me know in the chat. Go to next topic. Okay, great. What is next here? Let's see. Oh, this was the parenthesis one. This is the problem which we have with parenthesis, right? We have done it in last class also. This parenthesis one. Anyone wants me to explain it again? Or can we move into the next one? The parenthesis one. Next, right? Arad also said next. Okay, great. Okay, then we have our question on assignments, right? Finding out the maximum and minimum. I think this is, we did it in last to last class, maximum minimum element. And before that, we have one question of sort the element of stack recursively. And you should use stack methods like pop, push, and peek. You should not create a new array, but modify the existing array. It means, again, we are going to use the recursion for sorting the elements. Okay, so see guys, let me just quickly just remind you the logic, then we will move into the next question. So if we talk about the sorting, so just take randomly, right? 9, 1, 8, 3, 5. Correct? We want to sort this stack, right? And after sorting, our answer should look like this. So 1, right? And then I think 3, yeah, then 5, then 8, and then 9. Our answer should be looking like this. So what we will doing, guys? We will be popping out all the elements again. We will be popping out all the elements. Like first time we'll be popping at 9, then we'll popping out 1, then 8, then 3, then 5. Correct? And then when we will be in the 5, we will be again inserting it into the stack. Again inserting into the stack. So first 5 will go here. Okay, right now stack is empty. Okay, that's fine. 5 is there. Now 3 will go here. Now we will be comparing it. Which one is smaller? If 3 is smaller, if this 3 is smaller than the stack top, we will be popping out. We will be popping it out. So now 5 will go out again and stack will become empty, and then we will insert 3 here. And then the popped item, which is 5. Correct? That's what we are following. Now it will go for 8 as well, because 8 is already greater than that. So we can keep it on the top. 3, 5, and 8. This will happen for 8. Now let's talk about 1. Once the 1 will come, it's again smaller. 1 is smaller. So we need to pop it out everything from the stack which is lesser than, which is greater than 1. So once everything will be popped out. First 8, then 5, then 3. So first 8, then 5 and 3, everything will be popped out. And then 1 will be inserted here. Or we can say that insert at bottom. So everything, like whatever, if it is smaller than the top, we'll just inserting it on the bottom. Insert at bottom will work. Because if 4 is coming, if after 4 is coming, we do not need to insert it at bottom. Yeah, do not insert at bottom, guys. If 4 is coming in the middle, insert at bottom will not work properly, right? So just simply pop it out those elements till we got a greater element than this. Like right now 1, because all the elements are greater, that's why we are keeping it at the end. So now it will look like this. After pushing the 8, we will keep them back. But now what about 4? So what 4? Like you can see first element is 8, then 5, then 3, and then 1, right? Now 4 is coming. 4 is only smaller than this and this, not 3 and 1. So that's why 4 will be inserted between them here. 4, 5, 8. And 9 is already greater. It will be inserted here. So that was the logic which we worked for sorting it out. Parag is saying pop till empty, then push and check if small, then inserted. No, not inserted bottom, Parag. That's what I explained you. Inserted bottom can create a problem. For 4, you have seen that, right? Yeah. So we have to again pop it out everything till we got the smaller element than that. Till we got the smaller element than that, which we are trying to insert. Till then we will pop it out and then we'll stop. Then insert that element, then we'll insert all the popped items. Okay, so now let's move into, so do you guys want me to explain the max and min, or we can move into the next one? Okay, Chandu wants to see the code. Let's go into the stack. Sorted. I think it was in the stack too. Yeah, it was a sorted inserted. Yes. Sort slack. I written a sort slack. Oh God, it should be sort stack, right? Yeah, you can see, guys. First, we are taking all the peak element, all the popping element. See, you can see every time popping is happening here in sort stack. Write it correctly, sort stack, right? Sort stack. Everything popping is happening. So it means this step 9, 4, 1, 8, 3, 5. All the popping is happening. Then once all the popping is ending in the original array, we are going to pass it to the next function, which is the sorted insert. And you can see here, guys, till our stack is empty or peak element is lesser. Peak element is lesser, directly inserted. If not, if peak element is greater, do the popping for those elements. I'm not inserting at the end. Do the popping till we got the lesser element. And once we got the lesser element, push it. Same logic, right? Which I explained in the chat or in the drawing. Are we good, Chandu, with that? Yeah. And min and max, you do not want to discuss. So let's move into the next slide now. Let's open the next one. I think the next one would be next greater element. And those max histogram, those problems. Yeah, next greater element. Okay, so for next greater element, I will first share the screenshots, which we have taken it out, right? So these was very important problems. I have already told you while we were discussing about them, right? Next greater element, next first greater element, next first lower element, previous first lower element, previous first greater element. You guys are now remembering those things which we talked about on those days. We were very excited after learning these things because after solving only one problem, we were able to solve 4 problems. And with the help of these 4 problems, we were able to help, I think, more than 3 to 4 problems which were asked in Google or Amazon. You guys remember it now? Yes, still remember? Yeah, so let's quickly see that. So for finding out, so these are the rules which we have written it out, right? if somebody is asking us to find out the next first greater element, always loop will start from end, right? You can see previous first greater element, because it is previous, so that's why the loop will start from the 0th index. This is the first thing which you need to remember about the loop part. And because whenever somebody is asking about the next greater element, you have to reverse the answer also at the end. Correct? Are we good with this slide, guys? Or this screenshot? Yeah, I'm trying to explain it, Parag. So you remember about the sure, Hariran, we'll see that question. So Parag, with this screenshot, did you remember anything? When we were talking about the next element, you have to look for the greater. Okay, let me take one example. With the example, we will be better, right? So let's see, in going to the slide, let's see an example is there. We can take that one. Yeah, 2, 3, 2, 7, 3, 5, 4, 6, 8. 2, 7, 3, 5, 4, 6, and 8. Right, guys? So now we need to find out the next first greater element. Next first greater element. Okay. And for each of them, right? So I think what we did, we started with one stack, right? And for the next element, for finding out the next first greater element, we have to start from right side. Or before that, let's directly find it out first. So for 2, what will be the next first greater element? It would be 7. Correct? First you should remember what we are trying to do. Then we will look the logic part. For 7, the next greater element would be, I'm just not writing the index right now, guys. I'm just simply writing the elements. And if we do not find any greater element, we will simply put -1 at that place. Okay. So next first greater element for 7 would be 8. Right. Next first greater element for 3 would be 5. Next first greater element for 5 would be 6. Next first greater element for 4 would be 6. Next first greater element for 6 would be 8. And there will not be anything for 8, so we'll put -1. That would be our answer. Parag, did you remember now anything with this logic? Yeah? Okay, now let's quickly look into our coding part also. So I told you that whenever somebody was talking about the next part, always start your loop from the back side. Okay. So now our stack is empty. So we'll keep the, and in stack, we are only going to maintain, if somebody was asking about the greater element in the stack, always stack top should be greater. Always stack top should be greater. If somebody was asking about the lower element, always stack top should be lower, right? If it's not lower, then pop it out. If it's not greater, then pop it out. So right now stack is empty, so keep the 8 here. Keep the 8 here. Correct? Now you can see now 6. Now let's look for 6. Right? So yeah, now let's look for 6. So yeah, so now for 6, is the stack top is greater? Yes, it's greater. We'll simply push it. We'll not do the popping. Always stack top should be greater. You can see for 6, the stack top is greater. Okay, wait. Before that, we'll also insert answers in our array as well. Insert answer in the array. Let's start again from the 8. Okay, let's start again from the 8. So guys, let's see. For the 8, stack is right now empty. So there is no element in stack. So in an answer array, we'll put -1 at that place. When we do not have any answer in the stack, we'll put -1. Okay. After putting -1, we'll insert our 8 here. Are we good with this line? Because this one also one logic. Understood this thing? -1, 8. Anyone has any doubt? No, right? Okay, I have waited it, so nobody has doubt. Okay, now let's look for 6. I told you, stack should always have greater element. So right now, yes, 8 is greater than that. So for 6, next greater element would be 8. and then insert the 6 here. Now let's go for 4. Now let's look for 4. Now let's click. Is the stack top element is greater? Yes, it's greater. So it means for 4, the next greater element is 6. Then insert the 4 here. Now let's go for 5. Now for 5, let's look for the stack. Is it the top greater element? Is the stack top is greater? No. What we need to do here, guys? Pop it. And till we need to pop it. Yes, till we got the larger number. Until we find the larger. Yes, until we find the greater. Correct. So now for 5, 4 will be removed from here first. And next we got the 6. So this would be the greater element for 5. So we'll keep our answer 6 again. And then we will insert the 5 here. Correct, guys. Now let's look for 3. Is the stack top is greater? Yes. So 5 is the greater element for that. Now let's look for 7. Is the stack top is greater? No. What we will do, guys? We'll do the pop till we find the greater element. So now let's look back. We will find the greater element here, 8. So answer would be 8 here. Next, this is the greater element. Now let's look for 2. Is the element is greater? Yes. Keep the 8 here. That was the logic actually, guys. Oh, by the way, sorry. We have not pushed the 7 here. Sorry, guys. That's why 7 will come here, not 8. Yeah. So now everyone remember these things. Everyone remember this now. So this similar way in a lower work, and similar way work for previous as well. So that was the condition which we have written here. For previous, we need to loop start from 0th index and reverse the answer. And see, for greater, always look for stack top element. That top element should be greater than the current element. If it is greater, then push it, else do the popping. That's what we did. Same for lower also. Always look for stack top element, and that top element should be lesser than the array current element. If yes, push it, else do the popping. Because see, in this stack, we are only going to maintain the greater element, not the smaller element. Okay, can we move into the next question, guys, now? Are we okay with that? Let's jump into the next question. Okay. Yeah, so next question was this one. Remove adjacent duplicate recursively in the string till there are no duplicate left. So the question was, we have to remove adjacent duplicates. That's why the stack will help you here. Otherwise, it could be some other problems, but they mention adjacent duplicate. So right, like this, A, B, B, A, C, A. This is our string. They are saying we need to remove the adjacent duplicate. So we can see A and B, these are adjacent element, but they are not duplicate. So they will not be removed, right? B and B, if we look for B and B, these are adjacent and these are also duplicate. So we need to delete these two. After deleting these two, our answer will look like this, A, C, A. Now you can see, again, we are getting two adjacent element in our string, which are again duplicate as well. So we'll remove these two as well. And our answer will look like CA. And that would be our answer. Let me show you. You can see, after that, our answer is CA. Did you guys remember the logic for this? Everyone wants me to talk to, you guys want me to quickly talk about the logic? Or we can move into the next one? Everyone tell me this thing. Logic, okay. So see, Parag, the logic was, we'll take one stack here. Okay, we'll start from the first element. This is our first element, right? A. Correct? We'll start from first element, this element, and then we'll insert it into a stack because our stack is empty right now. So A would be inserted here, right? Then B, and we are again checking this B, is it equal to our stack top element? No, B and A are different. So we'll insert B here as well. correct? Then again third B. Okay, is this B is equal to top element? Yes. So pop it out. Pop this B out of it. So we will pop it out. Now A will be remain there. Correct? Now we will be going for next A. Is this A equal to the stack top element? Yes. So pop it out. So this A will also be popped out. Now our stack is empty. And we are at this place, C. So now, because the stack is empty, simply push the C here. Again A. Is it A equal to C? No. Push it here. And that would be our answer, guys. CA. Now remember logic, Parag? Yes. So can we move into the next question, guys? Yes. Yes, sum of subarray minimums. The same question is equal to sum of subarray ranges as well. So we will first understand the logic here quickly. Correct? Somebody was asking about the sum of subarray ranges also, right? So let's talk about this problem. Sum of subarray minimums. Let's take any, if we have any better example. No, 3124 is also fine. Let's take this one only. 3124. This question was nice question actually. 3, 1, 2, and 4. And we have to calculate the subarrays. First, we have to find calculate the subarrays for them. And in that subarrays, sorry for that. In that subarrays, we have to find out the minimum. Correct? If you see the slides here, so these are the subarrays for the 3, 1, 2, 4. You can see 3 was the one subarray, 1 was the one subarray, 2 was one subarray, 4, 3, 1, 1, 2. These are these are subarrays, right? And now we need to find out the minimum in all these subarrays. So you can see at the bottom, 3 is there, 1 is there, 2, because these are the minimum, right? If there is only one number, those are the minimum, those are the maximum. So 3, 1, 2, then we have 4. Between 3 and 1, we have 1. Between 1 and 2, we have 1. Minimum 2 and 4, we have 2. Then 3, 1, 2, we have 1. And then you can see similar that. And then at the end, we need to add all these minimums, and that would be our answer. Have you understood the question now? Anyone has any doubt in the questions? Can we now jump into the logic part? Chandu, Parag, Arad, Hariharan? No, sir. Okay, you didn't understood the question. That's what you want to say, right, Hariharan? No. Got it. We can move. Okay. We can move into the logic. Okay. Okay. Yeah. Okay. So, guys, if you remember, when I was talking about this problem, I have picked just one element from this array, and that was 2. If I want to make this element 2 to the smaller element in number of subarrays, how will I find it out? If I want to make this particular element is smaller in multiple subarrays, how will it happen? So we need to find it out. To the left of it, how many times this number will become smaller, or how many times on my right side this number will become smaller. Correct? That's how we can find it out. So like now let's look for 2. So if I am taking this array 1 to 4, will 2 will be smaller? Guys, I think you can speak it right now. Any one of you can turn on your mic. Otherwise, I have to come back to chat every time. So if I will make 1 as my, like if I take my array from here, will 2 will be the smaller? No, right? You guys are not speaking, huh?
No, sir.
No, right? Yeah. So the 1 will not be smaller, right? So this will be the right. And for the right side, if I look into the right side, so yes, 2 could be the smaller for 4 as well, right? This could be the whole array, right? So now we can say that this is the area which is going to give us, or which is going to make R2 as a smaller. So what we need to find it out here, on the left side, we need to find out the first lowest element. You can see one is the first lowest element, because if we got any lowest element, that element will start becoming smaller, not the current element. Right now, I am looking for 2, but we got the 1, so which is lowest. So it means that 1 will become now the smaller. So that's why on the left side, we need to find out the left side previous first smaller. And same for right side also, guys. Next, first smaller. This is what we need to do. And once we find it out, then we need to subtract it. So like, let's see again for this example, 3, 1, 2, 4. Let's take their indexes also. These are guys indexes 0, 1, 2, and 3. Okay, I'm writing it as an index of them. Now let's find it out. The next and guys, we were going to look for the indexes this time, not the element. So let's find out the previous lowest first element. And I'm talking about the indexes, not the element. Index, previous lowest first element, a first index. So for 3, the previous one would be, there would be nothing, so we can keep it as a -1. Right guys, what will be happen for 1? The previous left element, it would be again -1. Am I right? You guys can tell me in the chat, or in the, you can speak as well. For 2, the minimum element would be 1. What would the index? It would be 1. For 4, the minimum would be 2. Right guys? And now if I look for next lowest first index, I'm right now guys, again, I'm looking for index, not the element. Okay. So now for 3, the next lowest finance is 1. What is the index for 1? It's 1 again. So we'll put the 1 here. Look for 1. Next, first is smaller. Next, first is smaller is nothing. So we can take the whole length. So which is, I think, 4. We can take the 4 here. Let's look for 2. What is the next smaller? Nothing. We can again take the 4. What is the next first is smaller? It's a 4. Correct? So this was the 2 things. First we will calculate the previous lowest and next lowest. And then what we'll do, the index minus previous lowest first element multiply by next lowest first index minus index. It will give us the total number of subarrays that element will create. It will give us the total number of arrays that element will create. Now let's look with the 2 only. Let's look for 2. So now the for 2, you guys know that the first grid, the previous side is 1. So now subtract it. So index is 2 minus previous left first is 1. Multiply it. Next left is 4 and index is 2. So let's multiply. It's 1 multiplied by 2. So answer is 2. So now 2 is going to make 2 subarrays where 2 will be smaller, and those subarray would be 2 and 2, 4. Am I right guys? These are the 2 subarrays where 2 will be smaller only. Let's look for 1. Let's see guys. First let me come back to chat. Anyone has any doubt till now? Anyone has any doubt? Everyone good? Okay. Let's look for 1 also very quickly. Let's look for 1 because I think 1 will have more. So for 1, we are looking for 1. So index, what is the index for 1? It's 1. What's the previous value? It's a -1, will become +1. Multiply. What's the next left? Which is 4. Minus index would be 1. So I think it is making 2 multiply 3. It is making 6. So let's look into our UI. Is the 1 coming 6 times? Let's look into our answer. So first is coming here 1, 2, 3, 4, 5, 6. Yes, 1 is coming 6 times. Right, guys? So this logic is going to work there. And then what we'll do, we'll simply multiply. Whatever the answer is coming every time with this, we'll simply add it. So we'll do sum plus equal to same logic. Like in this, here, equal to sum plus equal. So every time whatever coming from here, we will simply add it, and at the end we will get the 17. Once we will iterate in all them, calculate the values, and we'll add them, at the end we will get the 17. I hope you guys have understood. Okay guys, now for the sum of some ranges, the last question in this slide, which was assignment question, I remember, right? That was also similar, like 1 2 3. This was example, right? 1 2 3. Second array is 1 2 3. So in this question, guys, let me explain the question first to you. So you are given an integer array. The range of sub arrays nums is the difference between the largest and smallest element in sub array, and then you have to return the sum of all those sub array ranges of nums. So it means now you do not need to only find it out the smallest, you also need to find out the largest. And once you find it out the largest, also you need to subtract them both, largest and smallest. And once you find it out, whatever the output is coming after subtracting largest minus smallest for the same number, you have to add all of them, and then we will get the final result. Do you guys want to? So sir, we are also multiplying with array of I. Yes, that's right, Hariharan. That's right. We are also multiplying with array of I. Yes. In this, after calculating this, because we are saying that 2 is coming. How many times 2 is coming? Yeah, let me take the code. Yes, I think we are multiplying it. Let me see the code. Sub array minimum. Oh yes, we are doing that. Yes, that's totally right. I minus previous, and yeah, we are multiplying this, and then we are multiplying array of I also. Yeah. So this value is telling, okay guys, this value is telling us how many time that number is coming. You know, this 2 is coming 2 times. This 1 is coming 6 times. So that's why earlier than that we have to do array of I also, which will give us the multiplication, like how many times that number is coming. How many, this value is giving us how many times that number is coming, and this is the number which I am talking about, which we are talking about. Is it clear now? Everyone, we have missed that line, but yes, that's totally right. Yeah, so for subarray max, for subarray range, we also need to find it out the greater element for the same things, right? Now next greater and the previous greater. Till now we are looking for the lowest one. This time we have to find out the greater and lowest element. And see guys, what we'll do first, we will add all the lowest one. Like the same logic will work for the lowest one. Same logic will work for the lowest one, and at the end we will get the sum. We also need sum at the end, and we have to do the similar thing for largest as well. And then we have to total sum of smaller and total sum of larger. We need to subtract it, and we'll get the final answer. Right? Like if I quickly do that, so let's calculate it. Previous lowest element and next lowest element. We'll do the, and this is index. So index is 0 1 2. Now tell me, previous lowest element -1, previous lowest element is 0, previous lowest element is 1. I'm doing it quickly, guys. Just follow it. Next lowest element is nothing, so length. Next lowest element nothing, length. Next lowest element is nothing, so length. Now, how many times things are coming? Let's calculate it. So index minus previous, multiply next minus index, and then in this array of I, and then add it into sum. Correct? So array of I is 1. We are looking for 1, and how many time is coming? Index 0 minus previous plus 1 it will make, and next index is 3 and minus index 0. So you can see here it will give us 1, it will give us 3. So 1 will come 3 times. So 1 will come 3 times. So we can say sum is 3 right now. Right guys? Sum is 3. Now let's look for 2. Array of I is equal to 2 right now. So 2 multiply by index would be 1 minus previous 0 multiply next index is 3 minus index is 1. So it would be 1 multiply 2, which will give us 7. So sum will become 7. Let's look for array of I is equal to 3. So 3 multiply by index would be 2, previous would be 1. Okay. Next would be 3 and minus index would be 2. Let's look. So 1 multiply by 1, 3 will come only one time, I think. So 3. So our sum would be 10. Right, guys? Are we doing any mistake till now? We are good, right? Are we good, guys? We have just calculated the previous lowest. Now calculate the next greater one. 1, 2, 3. Indexes are 0, 1, 2. Now calculate the previous greater element. So for 1, the previous greater element would be -1. For 2, previous greater element is -1. For 3, the previous greater element is -3, -1 only. Right, guys? Now let's look for next greater element. For 1, it would be 2, so index would be 1. For 2, it would be index 2. And for 3, the length. Right? Now let's calculate for them. Same logic. Array of I multiply by index minus previous multiply by next minus index. So array of I is 1. So index minus previous. So index is 0 and plus 1. Multiply next is 1 minus 0. Right? So it will give us 1 multiply by 1 multiply by 1. It will give us 1. So sum would be 1 here. Right? Now let's look for next element. Now let's look for 2. Or yeah, 2. 2 multiply by index would be 1 and previous is -1. So it will be +1. And next is 2 and -1. So 2 multiply by 2 multiply by 1. It would be, I think, 2, yeah, 4. So yeah, I think sum will be 5 now. Right? Now let's look for next 3. Now let's look for 3. So 3 multiply by index. Index would be 2 minus previous plus 1. Multiply next would be 3 minus 2. Right? So it would be 3 multiplied by 1, I think 9. So the sum would be 14 now. So this is for larger sum and this is for lower sum, which is 10. So subtract it. 14 minus 10 would be 4. And that would be our answer. You can see in the chart. The answer is 4. Understood, guys? Yes, here we are using all the 4 logics. Correct. Clear, guys? Okay. Great. What about this daily temperature? Given an array of integer, temperature represent the daily temperature. Written an array such that answer is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day, which is possible, keep answer as a 0 instead. Right, guys? So what we need to find it out? There are temperature array 73, 74, 75. We need to find out the warmer day in future. Warmer day in future. It means, you guys tell me, it means warmer day in future. Which one of the 4? Warmer day in future. Which one of the 4? Yes, next greatest, because warmer means more temperature. So we need to find out the next greater element. Yes. So you guys can, do you guys want me to explain this one? Or did you guys understood? Next greater element. Everyone understood? This is the next greater problem. We need to find out the temperature which is greater than in the future. Okay, now everyone had understood. Now let's go back up. I think we have the stock span as the next problem. Yeah, this was I think the sub-array minimum. Yeah, then we have a stock span. So stock span is also similar, guys. Here we are saying, they are saying that stock price, we need to find it out as the max number of consecutive day beginning today and working backwards where the stock price was less than or equal to today's price. Two things, we have to move backwards to find out our results, and the stock price should be less than or equal to today's price. So what we need to find it out here in one of the four from the backwards. No, next greater, how next greater nahi. Do we need to find out the next greater here? We are looking for the backwards, right, Vishal? So it should be previous, right?
Sir, I said it to left.
Sorry?
Sir, I said it to left. Next, we need to find next greater element to the left.
Okay. Got it. Yes. Totally right. Understood. I didn't read the left. I just stopped at previous, at the next. Yes. We have to find out the greater element to the left. The first greater element to left. Totally right. So did you guys want me to explain this problem, or can we move to next one? We have to find out the previous greater element to left. Wherever we have the previous greater element, that would be the place where the till there our stock price would be lesser or equal. That's what they are asking. We need to find out the stock price was less than or equal. So we need to find out the previous greater one. Previous first greater one. So when once we got the previous greater one, or on the left side greater one, at that place we need to stop it. Anyone wants me to explain the logic, or we can move into the next one? Next one. Okay. I think the next one is the histogram. We can delete this thing. Yeah. So next one is the histogram. So I think, guys, rather than going into the histogram, we'll start from the rectangle one, right? We'll understand that logic because both are related, right? Both are related. So we'll start with the rectangle one, and we'll also cover the histogram area, histogram logic there, right? Oh, break. Okay, so you guys want to go for break? Okay, so now it's 11:30. So we all can come back at 11:45. So let's come back at 11:45. Definitely, no problem. Yeah, let's come back at 11:45. Is everyone back now? Let me know in the chat. Suraj and Hariharan says yes. What about others? Vishal is also back. Okay, so now mostly everyone looks back. So let's jump into the next question of us. Yeah. So the next question was, which we were going to talk about, that was maximum rectangle. And with this question, we'll also talk about the maximum histogram area, right? So let's take this question there. So 1 0 1 0 0 1 0 1 1 0. Sorry, 1. It's at the last. It's 1. And then we have 1 1 1 1 1 1 0 0 and 1 0, right? And we need to find out the maximum rectangle which has the 1, right? So they are saying find the largest rectangle containing only ones and return its area, right? So you can see in this whole rectangle or in this whole matrix, binary matrix, you can say that only this one is the bigger one. This is the largest rectangle. And if you want to calculate the area, so the area would be 6 here, right? 3 1 these, 3 1 these here. Right, guys? So this would be the maximum rectangle which we will get here. You can say this is also one rectangle. This 5 1, but it's lesser size. Okay. Everyone understood the question now? Yeah. So now let's go back to solving this thing. So if you guys remember a little bit about this, so for solving this question, I told you, let's take one by one row, one by one, and calculate the maximum area histogram for that row. So let's take first row here, this one, 1 0 1 0 and 0, and just consider them as the height of. Now we'll try to solve the maximum area histogram as well. Okay, so now let's just consider these are the heights of a building. Okay, so let's create a building for them. So this is the height 1 building. This is height 1. Then we have a ground here 0. Then we have again height 1. This is the 0 here. And then we have 0 again, and then we have 0 again. See, these are the points. These are the points, right? 0 1 2 3 4 and 5. All the elements you can say of the array we have represented in our with a building height. Okay, now what we need to find out, guys, we have to find out the maximum area here. Correct. So for that, if you guys remember, let's quickly take some one example of histogram only quickly. Yes, no, we have not missed anything, just started. Because for understanding the histogram, this query, yeah, like this only, 6 2 5 4. Just understand with this example only. Okay, so you can see these are the buildings, right? 6 2 5 4 5 6 1. And if we want to just find it out, the larger number of bars or larger number of area here in this whole histogram, so we just need to expand every buildings here, and we need to find it out how much expansion we can do for each of buildings here, right? And then like whatever the maximum expansion we can do, we have to take the area of that. whatever the maximum expansion we can do, we have to take the area of that. So let's consider this 4 1. Let's consider this 4 1. How much expansion for this building we can do? So if we look for the left side, we can do expansion till 5 only, right guys? Till 5, because after that 2 is coming, which is the smaller in height. So that's why we can't expand it here. So we can only do till here. So this is the expansion we can do here on the left side. If we talk about the right side, same goes for next building, but after that we have 1. We can't expand that one. So we can do only expansion this part, right? So now 4 is there, and you can see width, how much width we have taken. This is the 1, this is the 2, this is 3. So total area would be 12 here for 4, right? For expanding the 4, we are going to get total area as a 12. So that could be one area we can save it one place, correct? Now let's expand some other buildings. Like if I want to expand the 6th one, we can't expand it. Not to left, because on the left side we directly have ground, and on the right side we have the height building of 2. We can't expand it. So the area for this building would be 6 only, because we can't expand it actually. Now let's talk about 2. If we talk about 2, we can expand it here onto the building of 6. We can definitely expand it. And then if we talk about the right side, we can expand till here, till 5, because after that we have 1. We can't expand it, right? So if we calculate the area now, so height is 2 and a width would be 1, 2, 3, 4 and 5. So width would be 10. Still this one is smaller, right? You can see here the yellow one. This one is till there, we can expand it only. Now if we talk about the 1, so 1 I think we can expand in all buildings, guys, right? So you can see the area would be 6 here. 1, 2, 3, 4, 5, 6, 7. Sorry, 7 here. Same for 6, we can't expand it. Same for 6, we can't expand it. Same for 5, these 5 buildings, we can't expand it. So I think the maximum area which we'll get from here, it would be 12. So we just need to expand it. So when we are talking about expanding it, let's talk a little bit technically about it. It means we are trying to find it out. The previous lowest element, you can see it's 2. We can't expand it after that. And then we are also trying to find out the greater right side element. Sorry, not the lowest right side element. Yeah, lowest right side element, lowest. Again, guys, first lowest right side and first lowest left side. First lowest right side, first lowest right side. You can see there only we can do the expansion. And after that, we have to calculate the width. We already have the height, and we'll get the area. Everyone understood the maximum area histogram? Everyone understood the logic? Yeah, are we good with that? Okay, now let's come back to the rectangle problem. And let's calculate the maximum area histogram here. So now you can see here, for building this one, where the height is 1, we can't expand it to the right side, we can't expand it to the left side. So the maximum area would be 1 here. Same for this one also. You will see we can't expand it here, we can't expand it here. So for this, the maximum area histogram would be 1. Are we good, guys? Everyone, for calculating the maximum area histogram for this particular first row? Yeah, now what we said in the maximum area, now we'll take these 2 rows, and wherever 0 is coming, we will not take that much. We will not add that one. So now you can see we will only add wherever 0 is, because if I'm seeing 0 anywhere, it means that building we cannot create. That building we cannot create. Wherever we are seeing 0, that building we cannot create. So that's why wherever we'll see the 0, we'll not take that one. So let's take here, because now we are not, both places we are seeing 1, so we'll take this one. 2, it's again 0 is already there. 2, 1 and 1. Now this is the building which we got next. Now let's draw this building also. 2, 0, 2, then we have 1, and then we have 1, like this, right? 4, all 4 elements are here. Any element we are leaving? No, right? Yeah. Now we can say here, now let's talk about again expansion. You can see this expansion, 1, 1, 1. So the maximum area of histogram is 3 here. Am I right, guys? You can see the maximum expansion of 1 could happen like this. Right, guys? So the maximum area could be 3 there. Now let's add the third one. Let's check there. So 1, 1, 1, 3, 1. Because in the last row we are not seeing any 1. We're not seeing 0. 1, 1, 2, 3 again 2, and again 2. Let's draw the diagram for this one also. So 3, 1, 3, and 2, and 2. Correct? Now let's do the expansion. If we do the expansion for 2, so if we do the expansion for 2, so it will be like this. Right? The maximum area would be 6 here. If we do the expansion for 1, if you want to do the expansion for 1, so maximum area would be 5, I believe. Yeah, so 1, 2, 3, 4, 5. Yes, so the maximum area is 6 here, which has been done with the expansion of 2, right? And now for the last one, I already told you in the wherever we will see whatever the next row we are going to add. If we are seeing 0, we'll not add it. So add this 4. So 4, we are seeing 0, will not take it. Again 0, not take it. And 3, again 0, will not take it. And I think in this one, 4 will be the maximum area because we can't expand anything here. So 4 will be the maximum area here. So in all of the areas, you can see 6 is the greater one. That would be our answer. Everyone understood the logic? We can quickly jump into the code as well. Yeah, everyone understood the logic? Let's jump into the code quickly. Max rectangle. So this is the MAH part. So we'll not take this one. MAH part is like the maximum area histogram is not the one which we should think about. Okay. Now you can see first what I did from the matrix, I am taking the first row, matrix 0. It means first row, and calculated the maximum area histogram for first row. Directly I have calculated. So for this row I have calculated it, and I got the answer as 1. I saved it in the first math here, and right now I'm considering that as my answer. Okay, till now I have not figured it out the next one, but till now that is my answer. Okay, now and I'm seeing, see, I'm also putting the condition. If somewhere I only got 1 row, so that would be my answer only. If in whole of binary matrix, if I only got 1 row, so that would be my answer only. Minimum area histogram, maximum area histogram. Now you can see, now I'm looking for the next rows. These are the second, third, fourth row. So what I'm doing here, I have to add it, right? So first I'm doing matrix I of j, wherever we are getting the 1. So matrix I of j and plus matrix I minus 1 comma j. It means the previous one. I minus 1 is this one, right? Always the previous one, previous row. So just add, I'm adding those one. If somewhere we are seeing the 0, we are not doing anything. After addition, we are coming out of for loop and going for minimum area histogram for that row. Like if we added this row, so now we are sending this row into the minimum area histogram function and finding out the minimum area histogram. And then we are comparing with our previous answer, that whichever the maximum area histogram is greater. And at the end, we are returning our answer. Everyone okay? Everyone okay with the code? Everyone good now? Yes? Okay, let's move into the next question then. And this question has been asked in Google. So guys, practice it. Okay, there was one more problem. Next greater element 2. Did you guys remember what we did here? Next greater element 2. And the problem, problem was the circular. If we have an array as a circular, so if we talk about the next greater element, we have discussed, right, somewhere, next greater element? Not here. Yeah, this was the question, right? 2, 7, 3, 5, 4, 6, 8. After 8, you can see we were not seeing any greater element. So we were putting -1 there. But in the next greater element 2, they were saying to us, you need to look for back side and then find out the first greater element here. Did you guys remember the question now? We have to look into the circular way for the next greater element 2. Anyone forget the question? Parag is saying no. Means you didn't remember, right, Parag? The question? Forget, yes. So let me open it. Next greater element 2. Yeah. So this was the code actually we did there for this, right? Yeah. So yeah, you can see there we have 1, 2, 1. Let's take this one only. 1, 2, 1. So next greater element for 1 would be 2. For 2, next greater element is not there anything, right? So we should be putting -1. Correct, guys? If we are talking about the next greater element 1, and then we'll solve the next greater element 2 as well. So for 1, we just need to look on the right side. So for 2, there is nothing on the right, we'll put -1. For 1, there is nothing in the right, we'll put -1. Right, guys? That's what, who was that? Parag, right? Let's come back to chat. Parag, understood this thing? Parag and Hariharan? Understood this thing? This
Yes, sir.
next greater element 1, right? So now let's look for next greater element 2. What we will do here? We will come back to the previous one. We will circular is back, circular is back, circle it back, and we'll look from this index. So now let's see. For 1, we already find out the greater element, so we'll put the 2 here. For 2, 1 is not the greater. We'll come back here. Again, we are getting the 1, which is still not greater. Again, we got the same element. So once we reach to the same element and we still did not get any greater element, we will say that again answer is -1. But for 1, this time solution will change, because we'll come back here. We'll see 1 is greater. No. 2 is greater. Yes. So answer will become 2 here. So that's the next greater element 2. Understood, guys? That was the problem. Are we good with now? Have we understood the problem now? Now let's look into the second problem one more to understand it better. 1, 2, 3, 4, 3. 1, 2, 3, 4, 3. 1, 2, 3, 4, 3. And we'll directly solve this time next greater 2. So for 1, next greater element is 2. Okay. For 2, next greater first element is 3. Fine. For 3, it's 4. For 4, it's 3. Okay. But for 3, what we will do this time? We will come back to this position and we'll find it out the next greater element, next first greater element from the previous time. 1 is not greater, 2 is not greater, 3 is not greater, 4. Yes, we got the 4. And that should be our answer. Let me check. 2, 3, 4, -1. Oh, 1 minute. For 4, I think we not doing it. Oh, yeah. Sorry. For 4, 3 will not be there, right? For 4, it should be -1 because we do not have anything greater than the 4. Everyone understood now the questions with these 2 examples? Yes, we have gone with one more example, Parag. Understood now? Parag? Little confused? Okay. Little confused? Okay. So Parag, in the next greater element 1, we were not coming back to this position. We were not coming back to, or like the first index. We're not looking from there. We're only looking to the next element here. And once the next element is ending, we are saying we have to return -1. We have to return -1. But in this scenario, we are also checking back to the previous positions. Earlier we were only checking to the next positions. But right now we are also checking for the previous positions. And as you can see, for 3, we do not have anything in the next, but we have the greater and the previous position. That's why answer is 4. But 4, there is nothing greater on previous, nothing greater on the right side. That's why we have put it answer as a -1. I hope you understood now. Does it make sense, Parag? Yeah, now got it? Yeah. So we have to check this time previous elements as well. So now if you guys remember it, how we have solved this problem, we have solved this problem because for a greater element, one next greater element, we maintain one stack, and in that stack we start looking from the back side, and then in our stack we just maintain all of the greater elements, right? If we talk about the symbol next greater element 1, NGE1, so what we'll do, we'll simply maintain this stack and an answer array, and once we see that the stack is empty, we'll do -1 here, right guys? We'll do -1 here, and then for remaining element we were able to solve it. For 3 it was 3 will be inserted. For 4 it's a smaller, for 4 it's a smaller, so we'll remove it because we have to find out the stack top should always be greater, but 4 it's not, so we'll remove it. Again our stack is empty, we'll do -1, and then we'll put the 4 here. Then for 3, 4 is the answer because it's a greater. For 2, 3 is the answer, right? We will push 2 here. Then for 1, 2 is the answer. That was the next greater element 1. We have already solved this thing, right guys? Next greater element 1, we have already solved this thing earlier, today's class only. But now there is just one problem for last element. There is a one problem for last, because see, for all the previous element we are already checking it. For the previous element we are already checking it, but for the last element we are not sure. So for that what we did, we have started looking from this element. First we started looking from this element, whatever, like just leave this element, just leave the last element and check in the remaining element what are the greater, which one is the greater. Leave the last element and check for the remaining element, which one is the greater, and keep it in the stack. So like, let's see, now we are going for next greater element 2. Next greater element 2, what we did, because we know that for all the remaining element the earlier logic is working. You can see earlier logic is giving us the answer, but for the last element we are not able to get the answer from the earlier logic. So what we did, we left this one, because for the last element there could be possibilities, there could be one greater element on the left side. So that's what we are going to do. We are just going to leave the last element. We're going to take this much array only, 1 2 3 4, and trying to traverse back from here. So again our stack is empty, we'll keep 4 here, right? Now again we'll check here for 3, stack top is greater, will not do anything here, will not push it here, or we can push it, no problem, we can push it 3, we can then push it 2, we can push it 1, correct? We can push it 1 like this. Now you can see all the elements before that they are in the greater way, we have pushed it into the one way. Now we have all these elements in our stack, we have maintained all the greater elements in a pattern here, which we have in the stack. Now let's go back to the previous solution, our previous solution, which is what was that, 1 2 3 4 3. Now start looking from this side, from 3. Now let's look into the stack. Is 3 greater than the stack top? No. So what we'll do, we'll pop it. Now let's look for 2. Is it the greater than that? No. Pop it. Now let's look for 3. Not. And now 3 greater than 4? Yes. So keep the answer of 4 as 4 and then insert it. And then it will go back to the previous scenarios. Correct guys? We just want to solve this problem, right? Because in the next greater element, we just have the problem with the last element. All the previous element, now we can work it, right? Same solution will work here. Like 4 -1 will be there, 4 will come there, 3 will come there, and 2 will come there. That would be your answer. And that's what we are looking at. So that's what, guys. For the next grid element 2, you just need to remember, because we are facing the problem for the last element, you will just ignore that one and we'll calculate for this thing. And we'll not calculate the answer. We just create the R stack. Because when we will start looking for 3, we should be having the first greater element here. Understood, guys? Understood. What about the last second element? Last second element, already we were, for the last second element, Arad, you are already getting the answer from first approach only. For the second last element, you are already getting the answer from first approach. Okay? And you just try it, Arad. If you have any other examples where you are thinking about the second last, let's look for 1, 2, 3. Will it, where was the 1, 2, 3? Oh, 1, 2, 1. Where we are changing the answer here. Here also, I think we are changing for last one only. Yeah. So this one, both questions are similar. But can't we take like for every element? Yes, we can. We are doing that, right, Arad? For every element, we are checking the previous one only. Can we see the code? Ah, yeah, code was also there, right? Yeah, it's here. You see? First, we look for the n-2. We are checking, we are maintaining our stack, all the greater elements. If there is no greater element, we are popping it out. For n-2, you can see n-2. So we are leaving the last element and checking from second last element. And once we have our stack maintained, now we are looking from the last element also, n-1, which will be last element. Then we are looking at our stack, and then at the end we are reversing our answer because it's the next greater element. You can see the code here. Just one step is there. Which one is this? Otherwise, this code is similar to earlier. But just one more step, just to fetch the previous value for the last element. Got it, guys? Can we move into the next one now? I think the next topic is going to start queues. Yeah. So already discussed the assignment problem. So let's now jump into the queues. Yeah. So next one is queue. So in queues, guys, it's again is the linear data structure, right? And I think when we were talking about the queues, we were talking about the same queue which we create while taking a movie ticket in hall. We have to be in one line, and that line, whoever is in the first in that line, that person will get the ticket, and whoever is in the last in that line, that person will get the ticket at the last, right? So that's what the queues strategy is: first in, first out, right? Last in, last out, right? So that's what the strategy queues follows. Same like stack follow little bit different strategies, but queue follow different strategy, but they both have similar methods. Like if we talk about insertion in stack, we have push method, but in queue for insertion we have enqueue method. For deletion in stack, we have pop method. For deletion in queue, we have dequeue method. And all other methods are similar here and there. Like we have underflow, overflow here as well, peak element, empty, those all methods are here. But one more difference is there. Like there are two differences we have talked about. First is the strategy, which is first in, first out. In stack, we have last in, first out. The second strategy or second thing which we have the differences here, and that is in the queue, we have 2 pointers, which is front and rear. You know, in the ticket, when we are taking the ticket in the counter, the first person who is standing in the queue, that person is known as front, because that person is going to take the ticket first. So that one is front. And all the other persons who are coming and joining in that queue or in that line, that position is called rear, right? If I show you this example also, you can see the front is the first person, right, in the line, and the rear is the position where the next person is going to insert. So that's what in queue, when we do the insertion, we do always it from the back side. And when we delete anything, we do it from the front side. Understood, guys? I know you guys have already understood these things. Are we good with that? Front, rear, NQ, DQ. Everyone, are we good with that, guys? Can we move further? No one is writing anything. What happened? Yeah, we can. Okay. So we can implement queue in similar way with the array or linked list. And we have seen both of the things. In last class, we have seen queues implementation with linked list. And before classes, we have seen queues implementation with array as well, right? So let's move further. Now we have DQ. DQ, it's different than your DQ method. All the queues have NQ and DQ method, but this is DQ. This is a different type of queue. This is one of the type of queue where you can do insertion or deletion from any of the position. Any of the positions mean from any of the pointers. Like you can do insertion also from the front, and you can do deletion from the back as well. Because in the queue, if you remember, we can only delete from the front and we can only insert from the back. But in the DQ, you can do insertion from the front as well, and you can do the deletion from the back as well. So that's what the DQ is, and we can implement it with the queue as well, with the linked list as well, with the arrays as well, right? So that was about the DQ, guys. So these are the methods: add back, add front, remove front, or remove back. So that was all about the queue. Can we move into the next slide now? Or you guys want me to cover any of the other topic here? Okay, so let's move into the next slide, guys. I think this should be the next slide for us. Yeah, the advanced problem on queues. We can close all these things. We can open it again, no problem. So the first problem is, guys, here we have been given a stream of characters. We need to find out the first non-repeating character from the stream. You guys remember the question? This, like, we have AB. We need to find out the first non-repeating character and then print it out. Like if we start from first index, which is A, right now A is the first non-repeating character, so we'll keep it here. Then we talk about the B. Now if we talk about the all of these two letters together, AB, is still A is the first non-repeating character. So that's why you can see second time we have also printed out A. Now in the third index, when we reach to third index, we got the A. Now A could not be first non-repeating character because A has been repeated. So now the B would be the repeating character, right? Now again we got when we reach to the fourth index, we are seeing again the second B. So now B has been already repeated. So there is nothing there is no character which is not repeated. So it means that's why we are keeping the answer as -1. Same goes for this one also. So A, B, till now A was first non-repeated. So there you can see 2 times A is coming. Now A, B, A. Now B is the non-repeating because A has been repeated. So now you can see B is the answer. You can see till till C, B is the first non-repeating character because B has not been repeated. So we are saying B is our answer till now. And once we got the B here, you can see we are keeping a -1 here because there is nothing in the queue. There is nothing in the queue. So did you guys understood this question now? Explain about DQ, sir. Okay. Explain about DQ first. Okay. So Chandu, in the DQ, in the queue, if you remember, we can do operation if you want to do the NQ operation, from where we will do that? Chandu, you tell me. If you can come, you can go come back to audio also. From the end side, yes, from the rear side. And if you want to do the DQ operation, from where you will do? If you want to do the DQ operation, from where you will do? From the front side. Yes, that was the limitation of Q. But when we talk about DQ as a type of Q, you can do both operations from any of the place. You can do the insertion from front, you can do the deletion from rear as well. That's the difference only in DQ. And the DQ which you are writing, that's the operation DQ. And right now I'm talking about DQ as a type of Q. Understood, Chandu? There are two things are related to DQ. One is the method where we delete the element, and another is the type of Q, which is DQ. Yes, that's all the difference in both of them. Okay, Chandu? Got it? You got it, Chandu? Yeah, remaining all same as Q. Like, but what is remaining there? There is nothing remaining, right? We have totally changed our Q. Q has two limitations. We can do insertion from rear and do deletion from front. Now we have changed this thing. So what is left in Q now? Nothing, right? When you said remaining all same as Q, what is left there now? Nothing, right? So that's what, it's a different type of Q. Okay, so now everyone is saying they are not getting the last problem. So let's draw that problem. A, B, A, B, A, B, A, C, A, C, B. Correct? So now what we need to do, guys, we need to print first non-repeating character. Always remember this thing. What understand first thing? What is this? First, two things are there which is important. First and second one is non-repeating character. Okay, now let's start with A. Is it first non-repeating character? You guys tell me. Come to unmute. Is it the first non-repeating character? Yes. So
Yes.
answer is A here. Now let's go for this B. Is this V first non-repeating character? First non-repeating character.
Yes, sir.
Is the V non-repeating character? Is the B first non-repeating character?
No, A is.
I think
still
yes.
the first.
B is the
Yes.
first.
Yeah, A is the first non-repeating character still.
So I didn't get this one. Why B is the first repeating character?
No, B is not the non-repeating character. That's what I'm saying.
So why didn't you write B then?
No, we have not write B. It's A.
I'm getting confused about this.
No. Okay, so I am not able to understand your question. You are saying why B is not non-repeating. You are asking this thing.
No.
Huh.
I said that B is first non-repeating character.
Why? A has not been repeated till now, right?
Okay.
See, start from the starting index. We are talking about AB as a whole string in these two letters, which is the first non-repeating character. That's what I'm saying. Two things you have to take. First and then non-repeating. So in between A and B, which is the first?
A.
A. And which is the non-repeating? A. You have to take these two things together. Which is the first non-repeating? It's A. Understood?
Okay, so we have to take like a string of length 2 every time.
No. We will increase our length now. We'll go here also. We'll check for this part also. See, okay. See, you have to first maintain Object. Let's maintain one object. Okay.
Okay.
There again, let's maintain one object, which is going to tell you non-repeating things, and just maintain one queue also. Okay. In this queue will tell us the first thing, first letter, first character, and this object is going to tell us the non-repeating thing. Okay.
Okay.
Now let's iterate this string. So first letter is A, right?
Hmm.
It's not available anywhere. So we'll put it into our queue. We'll put it into our object also and count as a 1 here, right? So now this is our answer. For first iteration, this is our answer. Are we good till now?
Yes, sir.
First iteration. Now let's go for second iteration. Second iteration. Okay. In second iteration, we got B. We'll put it B here. Count is 1. And we'll put the B after this. Correct? Now you tell me this queue is telling.
Okay. I mean, I think A is still the first non-repeating character. I got it.
Yes, A is still the first non-repeating character. So that's why answer would be A right now. Now let's go for again third letter, which is A. Now let's increase this value. Right?
Okay, now B becomes the first non-repeating character.
Now, yes, now 2, because 2 has been repeated, so we'll remove it from Q. And now again, Q top will give us the non-repeating character. So now answer would be V for third iteration. Now you can see at the fourth iteration, we got the B here. So now the increment of B will also become to 2. So once it becomes 2, we have to remove it from Q also, because this is no longer a repeating character, non-repeating character. So now our Q is empty, so we'll put the -1 here. And that was our answer. A minus B -1. Now let's do this for this also. We'll use the same object here. Okay, same Q. So for A, again, it's a 1. Keep it as the first element, which is non-repeating, because the count is 1. So our answer for first iteration would be A. Let's go for second iteration. We got the B. Now we are checking B's count is still 1 and A's count is still 1. So A would be our answer, and we'll push the B here. Correct? Now let's look for A again. Okay, now A has become double. Second, it means repeated. So we'll remove the A from our Q. And now you can see B is the one which is on the top. So on the third iteration, B would be our answer. Now let's look for fourth iteration, where we got C. So we'll put the C here. And now you can see B is still 1. B is still 1. So our answer would be again B. You're getting, guys? Why answer is B? Now for fifth iteration. Now you can see A. Again, A has been incremented to 3 and A has been pushed here. Correct? So now again, still you can see B is still a first non-repeating character, which is in the queue, because B's counter is still 1. So now again answer B would be B. Again the fifth answer would be. Now let's again look for C. Sixth iteration. C is become 2, but again still B is 1. So again B will put as the answer. Now let's look for B. Now you can see, guys, our B become 2. Correct? Our B become 2. So first this B will be removed. Again, now let's check for C. Counter of C. Oh, C counter is also 2. So we can't take this one also. Now let's look for A. Oh, again, A counter is 3. We can't take this one. Now again, our Q is empty. So now our answer would be -1. So that was the answer. And that was the logic also, guys. That's what we are doing in the code also. We are calculating the counter and checking it with the Q. Understood, everyone? I think in the LinkedIn, Likhit has provided one answer in the objects as well. Object counter. Everyone understood this thing? Anyone has any doubt? Hariharan, Vishal?
No, sir, I have understood it completely.
Ready? Okay. Parag. Are we good, Parag, now? Okay. So let's move into the next question quickly. Yeah, the sliding window maximum. This one is also interesting question. The question is 1, 3, -1, -3, 5, 3, 6, 7. So, and they have given one window size as 3. Right? So they have given a window size as 3, and in that window size, we need to find out the maximum element. Right? You can see 1, 3, -1. This is the size of window. In these three elements, which is the greater? Which is 3. You can see we have the 3 here. Now we will look for this one. In these three, which is the greater? This one. We'll look into these three elements. We'll see the 5 is the greater one. We'll look into this 3. We'll again see 5 is the greater. We'll look into these 3. We'll see, yes, 6 is the greater one. And we'll look into the last 3. We'll see 7 is the greater one. Everyone understood the question now? Anyone wants me to repeat the question? No? So let's go back. The answer part. Okay, somebody was saying anything. No need. Okay. Let's go for the logic part. So I have already told you about this question that we have to follow some steps. So first we have to take the two variables I, 0, I and j, which will tell us the window size. I will tell us the window starting point and j will tell us the window ending point. Correct? And we will take one q again here, just for tracking our maximum element. Just for tracking the maximum element. So let's start. Till our window did not hit, we'll maintain our maximum element here. So let's look for 1. Okay, so 1, there is nothing in the queue. Push it here. Now 3. 3 is greater because we have to maintain greater element. So we'll remove the 1 from here. And we'll push the 3 here. Now -1. Okay, because -1 is smaller, we'll not push it. Now you can see first window had been hit. 3 elements had been hit, right? So j would be at this position and I would be at this position. And how we calculate the window? J minus I plus 1 is equal to k. So let's see, are we getting that or not? So j, if we talk about the indexes, so j would be 2 minus 0 plus 1. Yes, is equal to 3. So 3 is equal to 3. So that's how we'll see our window has been hit. So now our window has been hit. We'll check in the queue. In the queue right now, what is the maximum element? It's the 3. So in our answer, we'll say for the first window, our answer is 3. Now we have to shift our window. Now we need to shift our window because we need to remove this one element. So we need to increase the value of I. We need to increase the value of I right from here. So, but before removing, we just need to check wherever right now I is that element was greater? Because you can see this element could also be greater, right? So because if that element is greater, we cannot consider that element for the further window. If somehow this would be 4, I told you with this example when we were talking about, if this element is a 4, then 4 would be here, right? Because 4 would be greater in this window. But now we are moving our window to this one. So we cannot longer consider this 4. So that's why wherever I is right now, we need to check that is the whatever element right now at the ith position, is that element is a greater element? If yes, remove it. But in this case, that's not the true, because at the ith position, it's a 1, but our greater element is 3. So we will not remove 3 from our queue and we will increase the value of I. Now our I will become removed from here and it will be moved to this place. I hope have you understood this thing? Because I think in the class also I've explained it nicely, but let me come back to chat and see that. Yes, we'll check if element at I is highest in stack, not in the highest in the like in the stack top, not it's first thing, it's not a stack, it's queue. So we'll check if element at the ith position is equal to queue top, then we will pop it. If the ith element is in the queue top, we will pop it. Understood, Arad? Yes. Okay, then we'll pop it. But in this case, it's not. So let's move further. Let's move further. So now our J will go to this place. So first check. Is this element greater than our Q as we were doing earlier? No. That's fine. Again, our window has been hit. So now again, 3 is still 3 is on the top. So we'll do the 3 again. Now you can see wherever I is and Q top, both values are equal. So now we need to pop it. We need to remove it. Now this 3 has been removed because this 3 cannot be longer considered for next window. So now 3 has been removed here. And our window has been moved further. Now our window will be here. And I will also be moved from here to this place, right? And our J will also move to this place. And now you can see our Q is empty. So simply push the 5 here. Whatever next element. And now for this window, because our window again got hit, 5 is the greater element. We again check -1 equal to 5, ith position, no. We'll move like this further and then we will stop it at the end. Do you guys want me to complete it fully or did you guys understood the logic now? You guys understood, right? We can move further to the next question. Okay, so Chandu want me to complete it. Okay, let me complete it. So now for this window, our maximum element is 5. So now we have already checked this is not equal. So we will not, ith element is not equal to Q's top. So we will not remove it. We'll move our window further. Now our window will go for this position. And value of I will also move to here. And value of J will also move to next element. So first what we'll check, is this element greater than this? Nahi. No, it's not greater. 5 is still greater. So now our window has also been hit. We'll check what is the greatest element in the queue. It's 5. So we'll again print out the 5 here. We'll again check, ith element is equal to Q's top? No. Then increase the value of I and increase the value of J and increase the window as well. 5, 3, 6. So now first we're going to check the new element which has come. Is it greater? Yes, it is. So first pop it out 5 and insert the 6 here, right? Now again, you can see window has been hit. What is the Q top right now? It's 6. So take the answer as 6. Right? Now 5 is equal to 6? No. So increase your window. Increase your window to here. Increase your I. And J to here. Now 7 is greater? Yes, it is. So we'll keep the 7 here. And now you can see answer will be 7. So that's what the answer is, guys. 3, 3, 5, 5, 6, 7. Are we good now, guys, with this? Chandu, are we good with that now? Can we move to next one? So now let's move to next one. So implementation is stack using queues, queues using stack, and LRU cache. I think this one you guys have already done it, right? Do you want me to talk about any one of these three problems? Queue using stack using queue, or LRU cache? LRU cache is bigger one, so I think we should avoid that one. What about the last two? Yes, we did all these problems last week only. We should move to next one. Okay. What about others? So Ekta, Arad, and Bishal says that. What about others? Chandu, Hariharan, Parag. Chandu also says yes. Parag also says next. And Hariharan also says next. Yes, you just guys need to practice it. So now I think all the problems which we are going to see, those all are, I think, just the whichever we have done recently. So advanced problem on queues we have did. So advanced problem now linked list was there. Then we have stack again, and then we have queues. The last class, right? So let's start from Qs. Let's go back from there. Or you want to see the stack and Qs, because that could go easily, right? Because we have already covered this thing in yesterday class only. So let's see again if any problem you guys is stuck. So first was binary number generation. You guys remember that? We have a strategy for that. Can someone quickly tell it? Can come back to the UI, like unmute themselves and can quickly explain it? Yes, adding 0 and 1 in the queue's first element. Yes, just need to practice it. First add 0 and then first add 1. Longest contiguous array. Which was that problem, Vishal? Okay, let's see. It's in the queues section, right? We are in the queues only, right? Longest contiguous array. Let's see. Queue using linked list. We are okay with that also, right? Queue using linked list. Already we done it. We'll go back. Vishal, we'll see that. We are going back. If you know about which problem, where is it, we can quickly look into that. Otherwise, let's move like that.
So you can open it on lead code.
In lead code, we have.
No. This question was also in the slide, but we can also find it on lead code.
Longest contiguous array. Okay. Not able to copy it. Let's search it. This one, maximum subarray.
No. It's after that one. You clicked the wrong one, I think.
This one.
Yeah, this one.
Longest contiguous subarray.
Yeah, with absolute difference.
Less than or equal to limit. Okay, so what we did here? Let's see. Given an array of integers, nums, and the integer limit, return the size of longest non-empty subarray such that the absolute difference between any two elements of this array is less than or equal to limit. We have done this, I remember. So what we did, I think we have to find out the minimum or smaller than subtract, something like that. Let's see. 8 is there, so 8 minus 8 is 0. Yes, it is less than or equal to 4. Great. 8 comma 2, 8 minus 2 is 6, is greater than 4. Okay, let me see where this problem is. We can quickly look into the code one. This one, subarray minimum? No, that one. We have done it earlier.
I have seen it. I saw it on GitHub profile of yours yesterday only.
Yeah, I remember this problem. We have done it. I remember.
The question is like we have to find a subarray, and if we have to take any two elements, the difference should be less than or equal to the given limit.
Correct. Totally right. And therefore the answer size of longest subarray is 2.
I tried it, but like the last few cases are giving me like the time limit exceeded kind of thing.
Okay. Let me think about it. What we did here. I remember we have taken some variable size window, and in that window we were trying to look for the differences. Let me see if we have the code quickly. I think in the GitHub, right?
Yes, it's in GitHub.
Where in the problems?
In the queue, I think.
Queue. It's in queue. Okay. Oh yes, difference subarray. This one, right?
Yeah, this one.
Okay. So we will be having here, right? Oh, it has been removed here. 1 minute. Stack queue difference subarray. Yes. So let's quickly look into this one. Okay. Okay. We were trying to maintain two arrays there, or two queues actually, where we will be doing the max and min. And then what we're trying to do here? Then if the max 0 minus min 0 is less than or equal to limit, we have to do continue. We have to continue looking for the next element. Okay. And if not, then what we are doing here, num is equal to nums left, and okay, and if max 0 is equal to num remove it from the max. Acha, we have to remove it from min, and then we are doing the left plus plus. And where we are, what about the right? Acha, we are already doing the right plus plus there. Okay, I remember this thing now. Let me think. Let me right now explain this logic. Yes, it was little bit complicated. I remember this question. Yes, let's take this input from there. Let's take this one only. 8, 2, 4, 7. 8, 2, 4, and 7. Okay, guys, this is our array. And you know, let's understand first the question. What question is saying? They have given one array integers, and then they have also given us limit. And then they're saying return the size of longest non-empty subarray such that the absolute difference between any two element of this subarray is less than or equal to limit. Is less than or equal to limit. So let's see. First, create the subarray of it. By the way, you can already see it here. 8, 8, 2, 8, 2, 4, 8, 2, 4, 7. Then with 2, 2, 2, 4, 2, 4, 7. Then with 4, 4, 7, and then 7 is alone here. These are all the subarray which we can create here. And they are saying non-empty, so we do not have any empty array here. Then what they are saying, in each of the subarray, they are saying in each of the subarray, you need to find out the absolute difference between any two element of that subarray. And that difference should be less than or equal to our limit. So now if I talk about the one element only, so there is only if you talk about the one element, so that is only maximum and that is only minimum, right? So maximum minus minimum will get the 0, which is less than or equal to limit. So that array could be our answer. That array could be our answer. So they are asking about the size of that subarray. So the size is 1. So 1 could be one of our answer. Then now look for 8, 2. Now we have two elements here. So now we can simply difference them. 8 minus 2, 6, which is greater. So this is not going to be our answer. The size of this array is not going to be our answer. Now let's look for 8, 2, 4. So 8, 2 already will give us 6. So no need to make the difference between 8, 4, because 8 minus 2 is already 6. So this subarray definitely not going to make our answer limit less than or equal to 4. So that's why this will not consider. Same will not consider 8, 2 here again. Let's look for 2, 2, 4. 2 minus 2 will give us 0. We are okay with that. What about 2, 4? This will also giving at 2. So now you can see, guys, our size has become 2, 4. Earlier our size was 1, which was accepting our answer. But now you can see 2, 4 is also accepting our answer. So our size has become 2 now. Now let's look for 2, 4, 7. Will this also make our answer? No, because 2, 7 is giving us 5, which is greater than 4. So somehow 2, 4, 7 is not going to help us. And 4, 7, 7, because these are size 1, 2, doesn't matter if we check for them or not, because we already got the maximum 2 here. So we do not need to check for the size of maximum 2 here. Size of. Everyone understood the question now? Everyone understood the question now? We have to first find it out the subarrays, and in the subarray we need to find out, subtract each element of that subarray, and then we have to, after the subtraction, the result which are coming, that should be less than our limit or equal to limit. Parag, Chandu, understood you guys? You guys understood the problem? Binary number generation was very easy actually. We just need to add 0, 1 in the number. Okay, we'll talk about it after discussing about the logic here. Okay. Yeah, we are going to talk about the code now. Okay. Okay. So now so guys, as we can understand, in each of subarray, we need to find out the largest or the smallest element. If we talk about 2, 4, 7, if this is our array, if we find out the difference here, so see, one would be 2 minus 4, second would be 2 minus 7, or 4 minus 2, or 7 minus 2. Okay, right? These 4 combination only. Am I right? And you can see 5, 2, 2, and 5. So you can see all of them in all of these 4 combination, who is going to give you answer? And that is when you are subtracting larger minus smaller, larger minus smaller. In each of the sub array, you just need to subtract larger minus smaller. That value is going to provide answer. You do not need to subtract everything in the sub array. You do not need to subtract 2, 4 also, because you just need to find it out in each of the sub array which one is greater, which one is the greater, which one is the smaller, and just you need to subtract those things. Everyone understood this thing? What we need to do here? We need to somehow in each sub array find out the greater number or the smaller number, right? And we need to subtract it. We do not need to subtract each element in that array, in that sub array. Okay. So what we'll do, guys, we have taken 2 queues here. First for maintaining or tracking our max element, and second for maintaining or tracking our min element. Correct? And then we have taken 2 pointers. I remember. Then we have taken the 2 pointers, left and right. Then we have taken the 2 pointers there. In starting, both are starting from same place, right? Left or right or end? Oh, right or yeah, left and right. Yeah, left and right. Correct. Left and right. And then we have taken 2 queues here. In first queue, we'll maintain the max, and in second queue, we'll maintain the minimum. And left and right will maintain our sub array size. Left and right will maintain our sub array size. So right, sub array like same like window. However, whatever the window size will increase, we'll simply increase our left and right in that way. Understood, guys? Left and right are going to maintain our sub array size or the window size. So in starting, both are at 0 place. In starting, both are at the 0 place. Correct? So now let's see. First maintain. First we'll check. First we'll check, and we'll start from right side. Oh, by why I'm removing this? Yeah. So let's start from the right side. Both are at the same place right now. Left is also here, and right is also here. Correct? At 0. Left also here, and right is also here. Okay, tell me first, guys. You guys have understood why we have taken 2 queues, why we have taken 2 pointers, left and right, and what left and right is going to provide us. You guys tell me in the chat or wants to speak. Did you guys understood? Anyone had any doubt why we have taken left and right and why we have taken 2 queues? 2 queues for just maintaining the maximum and minimum element, and left and right for maintaining our window size or sub array size. Everyone understood? Yeah. Okay. Now let's move further. So now our left and right both are at the same position. Okay. And there is nothing in the max and minimum. So first insert this element in max and minimum both places, because you can see right now both are at same place. So right now our sub array size is 1 only, because both are at the same place. Left is also, right is also. Left is going to tell us the starting position of our sub array, and right is also going to tell us the end position of our sub array. But right now both are at the same place, so that's why both are at the same place. So first we will put all of them here. Max is also 8, min is also 8, because this is one array only. In one sub array, we have already seen max would be the same number and min will also be same number. Am I right, guys? Am I right, guys? We would be the same place. Correct? Now let's calculate the difference here. Let's calculate the difference here. And our limit was 4. Our limit was 4. So we have to subtract max and minus, max and min. And we have to find it out. Is it equal or less than limit or not? If yes, then this could be one of our answer. This could be one of our answer. So let's see. Max minus min. Is it less than or equal to limit? Limit is 4 and 8 minus 8. 0 less than equal to 4. Yes, it is. It is. So this could be one of our answer. We will not remove these elements. We will not remove this element because we now we need to just increase the size. We just now increase the size of our subarray, because this is first subarray, which is 8, which is giving us the proper answer. But we need to find out the maximum size. So we need to increase our subarray. So for that, we will first increase our right. Correct? For increasing the subarray size, we'll increase our right. Everyone understood why we are increasing our right? Everyone understood? Yes? Oh, guys, every time we need to actually increase our right. Every time. Okay? So now we can say, now we are comparing two elements. So now let's do first maintain the max and min. Now that this element, new element is coming to us, which is 2. Now again maintain the max and min. So 8 is maximum. Yes, 8 is maximum. But what about the minimum? Is minimum is okay? No. So we need to remove this 8 from here and keep the 2 at this place. Correct? And here we can also push this 2, because we will not remove the 8, but we will simply push the 2 here, because in somehow if somehow we need to move our window right now. See guys, we are just talking about 8,2, but somehow there could be some scenarios where we do not need 8. So in that place, we will remove this 8 from here. At that time, we will move our left to the, we'll move our starting point of subarray or starting point of window. But till now, we are okay. Till now, we are okay, because we have not checked the max minus min. Or I'm writing max minus min this place. Max minus min, it should be less than equal to limit. So now guys, this is the latest situation. When we have come to this place, when our right is this place, we are checking this much size. So now let's again compare it. Max is 8 and min is 2, which is giving 6, guys, which is greater than our limit. It means we can't accept this array of size. This sub array we can't accept. It means this sub array is not going to give us any answer. If we are going to add any other further element into this, like 4 and 7, it is not going to help us. Will it help? Will it help? If I'm going to add, if I'm going to move or increase the size of subarray, will it help? Because 8,2 already giving us 6. If we add any other element into that subarray, it will not have. So what we need to do here? We need to increase our left now. We need to increase our left now. Right is already increasing. Right we will definitely increase. But we also need to increase this time left. Am I right, guys? Because we need to now, we no longer consider 8 in our subarray, because 8 is making our answer greater than limit. So we can't take 8 now. So we need to increase our left also. Understood, guys? Everyone understood why we need to increase our left? Chandu, Hariharan, Parag. Did you guys understood why we need to increase our left now? We will definitely increase right, but we also have to increase our left now. Okay, so now what we'll do, guys, before increasing our left, we just want to check in our max or min array, is that element exist in the top or not? Because now we do not need to consider that element in our calculation of max or min. So we need to remove it from there also. So yes, so left is 8, that exists in max right now. So we will remove it from there as well. Now guys, thing will start from 2. Now thing will start from here, and definitely right will increase to this place. Correct, guys? Now our subarray will start from here. Correct? So now we'll check for 4. Are we good till now? Guys? Are we good till now? 2 also. No need to check, guys. No need to check, Chandu. Because we have already compared 8,8. We already got that size. 0. So no need to compare 2,2 this time. 2,2 will also give us same size. We have already compared 8,8 at the first iteration. Same number will always give us the same result. So no need to compare it 2,2. Okay. So now our subarray size is 2,4. These 2 elements are there. You can see left is there and this. So 2 elements are there. So now first compare the 4. 4 is greater than max? No. So first, fix our max Q. So 4 is there. Now 2, yes, we are good here. We are good here. So now do the calculation of max minus min. So 4 minus 2 less than equal to 4. Yes. Now we got little bit better size, which is 2, right? Which is 2. So now we are okay. We can consider. Now what we need to do, guys? You tell me. When we are okay with this size, we need to increase our subarray size. We need to increase our subarray size. Right, guys? Yes, move our right pointer. And don't need to move our left pointer. So move our right pointer to this place. Now you can see the size of our subarray. Now our size has become 2, 4, 7. 3 things are coming there. Correct? 2, 4, 7. Now let's check again, same thing. Max or min are okay or not? So we can say no, max has become 7 now and min is okay. Min is still okay, right? 2 is min. So correct, min is still okay. Now let's do the subtraction. So max is 7, min is 2, which is 5, which is greater than limit. Now you know, guys, what we need to do. Once we are going above our list, we need to reduce our window size. So now we will increase our left. Correct? But before increasing left, we need to check in our max or min Q that element should not be present, because that element we do not need to consider it. So that's what we'll remove the 2 from here, and then we will increase our left to this place. Correct? And now we'll move our right to outside. So that's what I'm saying. Right will always increment. Once you are like coming back to the next iteration, right will always move. So now we will compare 4, 7. Now like by the way, we do not need to compare 4, 7 because the size of 4, 7 is already, we know that 2. It's 2. So we do not need to compare it now. We have already checked everything here. Okay, but even if still you want to compare it, so let's we can compare it also, because see, after 2, 4 has been inserted here, right? And then 7. See, we are inserting every time elements here, right? So 2 has been deleted, 4 is here. So now you can do the same thing. 7 minus 4 is equal to 3, which is okay. No need to increase right or anyone, because we do not have any other element. So that would be the whatever the last window size is, we are going to take that one. So right minus left, what would be that? So 0, 1, 2, 3, 4. 4 minus 2 is equal to 2. So this is the window size which we are going to take it as an answer. You know that, right? 4. But let me check in the code. Are we checking it or not? The last element. When we compare, check it one. You can see, guys, right I'm increasing as I'm entering into the loop. You can see that I'm increasing right as I'm entering into the loop. Okay, so right is less than nums dot length. When right is less than nums dot length, yeah, I think we are not checking 4, 7. 4, 7 we are not checking with the logic as I can understand. We can see while right is less than nums dot length. So right would be less than nums dot length at this position 3. When right would be here, at that time right would be less than nums dot length. Once right will go here, it will not go inside this loop. And I think yes, we do not need to check 4, 7 now. We do not need to check last 2 element. So that's why the right minus left will give us the answer. And because we are already incrementing right side window. Got it, guys? You can see in the code also. That's what, oh, I have not told you the code. You can see, first I'm taking the right value from the right pointer, directly doing right plus plus, and then checking in the max array first, then checking in the min array for maximum and minimum, then pushing the same number in max and min both places, then checking our condition, max 0 minus min 0. If the value is less than limit, continue it. No need to do anything. But if the value is not less than 0, we need to increase our left pointer. And then you can see before incrementing our left, we are simply checking it that element which is the on the left should not be available on the Q top. So you can say I'm checking in the max as well, in the min as well, and I'm removing it. And then I'm doing my left plus plus. Question was not tough at all, guys. Hope you guys have understood. Have you guys understood this question now? Question was not totally tough. With the logic, you just need to maintain max and min, and you just need to increase your pointers, and those pointers are sub-array size. Okay, so now we have already spent more than 5 minutes, but before that, Chandu wants to understand the binary logic. So let me show you that also. So Chandu, if there are 1, 2, 3, 4, 5, the question was you have to generate 1 to n binary numbers for that. If I'm considering n as a 5, so you have to generate binary number for 1, 2, 3, 4, 5. Okay, and the binary number for them are this 1 0 1 0 1 1 1 0 0 1 0 1. Yeah, this was the binary number for these numbers 1 2 3 4 and 5. So you can see one pattern which we are following here, which is if you take this first number, we are just adding 0 in that, and then we are adding 1 into that. Same, take this number, we are adding 0 into that, we are adding 1 into that. So that's what actually we did. We have taken one Q, and in that Q, first we inserted 1 there. Correct? Then we taken it out with dot shift. With dot shift, we taken it out. So now 1 is outside, our Q is empty. Right? Now we added 0 into that and then pushed it. So 1 0 has been pushed. Then we added 1, we also pushed it. So now these two elements are in the queue. Again, we do the shift. Now 1 0 will come to us. Again, this 1 0 has been removed from here because we have already shifted. Now add 0 into this, add 1 into this, and pushed it. So that's how actually the code was working. When you are shifting, console it. Console.log. Whatever you are shifting. First time you will shift 1, so 1 will be console out. Second time you will shift 1 0, 1 0 will be shift. Second time I think you are going to shift 1 1, 1 1 will be printed out. Third time 1 0 0 4, 0 0 will shifted. Then 1 0 1. And that was your answer. Understood, Chandu? Okay, guys, so that's all from today. I hope some of the practice, some of the previous problems, you guys, where you guys were facing problems, you guys have understood it now. So, so all the best for your test tomorrow. And please do the practice. And while you are doing the practice, also share it on your LinkedIn, as we have already discussed before class today. And when you have little bit time, start reading about trees. Okay. Yes, definitely it will help. Yes. Okay, guys, have a nice weekend. Bye bye. We'll meet on Monday. Bye bye.